Imagine for a moment that you are standing outside on a clear night. The air is cool and still. Above you, the stars stretch out in every direction, countless and ancient, scattered across a darkness so deep it seems to breathe. You have stood under the sky before, perhaps many times, and perhaps, like so many people who have ever lived on this earth, you have looked up at those distant lights and wondered, quietly, whether somewhere out there something else might be alive. For most of human history, that question had no answer. The stars were beautiful and unknowable, and the planets were little more than wandering lights, slow and silent, tracing their paths across the seasons. We knew they were worlds, but we also knew, or believed we knew, that they were not worlds like ours. They were too hot or too cold or too crushed or too empty. They were neighbors only in the astronomical sense, present but unreachable, familiar in name but alien in every way that mattered. Now imagine that changes. Not slowly the way science changes things. Not over centuries of gradual discovery, of telescopes and rovers and careful equations. Imagine it happens all at once. Overnight, or perhaps in a single, impossible moment, something shifts. Something vast and quiet and beyond any human explanation reaches across the solar system and rewrites the rules. And when the sun rises the following morning, every planet in our cosmic family, every last one of them, is alive with the possibility of life. What would that mean? It is a question worth sitting with. Not rushing past, not answering too quickly, but really sitting with. Because the implications are enormous. Not just scientifically, not just in terms of where humans might travel or settle or explore, but in terms of something deeper, something that touches the way we understand ourselves and our place in the universe and what it means to call a world home. For as long as we have known that Earth is a planet, one planet among others, circling one star among billions, we have quietly carried a certain weight. The weight of uniqueness. The sense that life, fragile and extraordinary, had found exactly one foothold in all of this vastness. One pale blue world, tucked in a narrow band of warmth around an ordinary star, where the conditions happen to align just precisely enough for something remarkable to happen. That loneliness, that singular nature of our world, has shaped us more than we perhaps realize. It has shaped our philosophy, our religion, our science, our stories. The idea that we are alone, that Earth is the only cradle, the only garden, the only place where the universe has looked back at itself through eyes, is one of the defining background notes of human civilization. But now, in this quiet imagination, that changes. If every planet in the solar system became habitable, humanity would no longer see Earth as the only cradle of life, but as just one world among many peaceful cosmic homes. Let that settle for a moment. One world among many, not the exception, not a miracle, still precious, still beautiful, still worth protecting, but no longer alone, no longer singular. The solar system, which we had come to think of as a largely empty and inhospitable place, dotted with the occasional interesting but lifeless rock, would suddenly reveal itself as something altogether different. A community of worlds. A family in the truest and most unexpected sense of the word. And perhaps the most transformed of all those worlds. The one whose change would be most dramatic, most visible, most almost unimaginable to anyone who has ever studied it, would not be the cold and distant planets at the edges of the solar system. It would be one of our nearest neighbors. It would be Venus. Venus, which in the night sky burns brighter than anything except the sun and the moon. Venus, which ancient civilizations mistook for two separate stars because it appears both at dusk and at dawn. Venus, which in photographs looks like a soft and luminous pearl wrapped in golden clouds. Venus, which upon closer examination reveals itself to be one of the most hostile environments in the entire solar system. The surface temperature of Venus, on an average day, is around 465 degrees Celsius. That is hot enough to melt lead. The atmospheric pressure at the surface is roughly 90 times that of Earth, the same pressure you would feel if you dove nearly a kilometer beneath the surface of the ocean. The clouds are not made of water. They are made of sulfuric acid, and they are so thick and so reflective that the surface of Venus is trapped in a kind of permanent, crushing twilight, heated to extremes by a runaway greenhouse effect that began long ago and has never stopped. Venus would experience the most dramatic transformation of any world in the solar system, changing from that crushing greenhouse hellscape into a planet with blue skies, with rainstorms, and perhaps even with shallow tropical seas. Close your eyes for a moment and try to picture it. The acid clouds dissolve. The thick blanket of carbon dioxide thinning, replaced by something cleaner, something breathable, something that allows sunlight to fall on the surface not as a smothered and diffused orange glow, but as actual warmth, real and direct and golden. And then, perhaps, moisture, water, which may have existed on Venus billions of years ago before the planet's climate tipped into its long disaster, returning, gathering into clouds, falling as rain. Rain on Venus. Real rain. Not sulfuric acid droplets that evaporate before they can reach the ground, but water cool and clean, falling onto rock that has not felt it in billions of years. Pooling, running, finding the low places, the valleys, the ancient craters, and beginning slowly to fill them. And because Venus is in many ways a twin of Earth, similar in size, similar in mass, similar in the fundamental composition of its rocks, a habitable Venus might not look entirely unlike a tropical version of our own world. Warmer, perhaps, closer to the sun, but with blue skies above and shallow seas below, and the particular humid, heavy air of a planet still learning how to breathe. It is a remarkable image, and it is only the beginning, because even as we are imagining Venus reborn, turning our gaze slightly outward, we encounter another familiar name, one that humanity has dreamed about for longer and with more intensity than perhaps any other world. A planet that has captured our imagination since the first telescopes turned in its direction and revealed its polar ice caps, its seasons, its dust storms, its thin but unmistakable atmosphere. Mars. Mars has always occupied a special place in the human mind. In the 19th century, serious astronomers believed they could see canals on its surface, long, straight lines they interpreted as the engineering works of an ancient civilization managing a dying world's water supply. That turned out to be an illusion, a product of human pattern recognition working overtime across the vast distance between worlds. But the dream behind it never entirely died. The dream of Mars as a place where life existed, or had existed, or perhaps could exist again. In our imagination, it does. Mars could finally support open rivers and forests without any need for domes, without spacesuits, without the hermetically sealed bubbles of artificial environment that would be necessary on the Mars we currently know. Humans could walk on its surface beneath natural clouds, looking up at a sky that is perhaps not quite the deep blue of Earth's, but something softer, something hazier, the kind of sky you might see at high altitude on Earth, pale and vast and full of light. The sun, viewed from Mars, would appear smaller than it does from Earth, roughly 2/3 the size, and yet still unmistakably the sun. Still warm, still life-giving, still tracing its arc across the sky from east to west while the red world turns slowly beneath it. And the rivers on a habitable Mars might be one of its most breathtaking features. Because Mars is not flat. Mars has topography so dramatic it dwarfs anything on Earth. Olympus Mons, a volcano so large it would cover the entirety of France, rising 22 kilometers above the surrounding plains. Valles Marineris, a canyon system so vast it stretches the distance from one coast of the United States to the other. Rivers on Mars would have extraordinary landscapes to carve through, extraordinary valleys to fill, extraordinary cliffs to pour over in waterfalls that no human eye has ever seen, and forests. Imagine standing in a forest on Mars. The trees would likely be strange, adapted to a world with lower gravity, perhaps growing taller than Earth trees, or spreading their branches wider. The light filtering through their leaves would have a slightly different quality than Earth light, slightly more orange, slightly more distant. The wind would move differently in an atmosphere less dense than ours. Everything would be familiar in the deepest sense, because life is life and growth is growth, but tinged with the unmistakable signature of another world. Now we move further along the solar system, away from Mars, away from the familiar inner worlds, into territory that grows stranger the deeper we go. Mercury, the smallest of the 8 planets, the closest to the Sun, a world that, more than almost any other, seems to occupy 2 extremes simultaneously. During the long Mercurian day, temperatures on its sun-facing side soar to over 400 degrees Celsius. And during its long night, because Mercury rotates so slowly that a single day on its surface is nearly 60 Earth days, the temperature plummets to negative 180 degrees. That swing, from searing to freezing, from one extreme to the other, happens with a grinding geological patience that no life form we can currently imagine could survive. For Mercury to become habitable, it would need a stable atmosphere and slower temperature swings. It would need clouds to distribute heat more evenly around the planet. It would need something to hold the warmth when the sun sets and to moderate the extremes when the sun rises. In other words, it would need something like what Earth has, that thin, precious, perfectly balanced layer of gas that we breathe without thinking, that wraps our world in a kind of thermal blanket that makes life not just possible but comfortable. A habitable Mercury with oceans, with clouds, with breathable air would be one of the most sun-soaked worlds in human experience. The sun, viewed from Mercury, is enormous, nearly 3 times larger in the sky than it appears from Earth. A sunrise on Mercury would be unlike anything ever witnessed. Slow and overwhelming. A burning wall of light creeping over the horizon of a world that has been dark and silent for weeks. But then, as we move outward from Mercury and Venus and Earth and Mars, we reach the place where the solar system changes character entirely. The asteroid belt. And then beyond it, the gas giants. Jupiter. Jupiter is a world on a scale that is genuinely difficult for the human mind to hold. It is so large that more than 1,300 Earths could fit inside it. Its great red spot, a storm that has been raging for hundreds of years, is itself larger than the entire Earth. It is a world of clouds. Ammonia clouds, water clouds, clouds of ammonia hydrosulfide, banded in gorgeous browns and oranges and whites, swirling in patterns of almost mathematical beauty. But there is no surface. That is the thing about Jupiter that takes some adjustment to fully accept. There is no ground, no rock to stand on, no beach, no mountain, no valley. As you descend through Jupiter's atmosphere, the gas simply grows denser and hotter, transitioning gradually from something like air into something like a liquid, and eventually into conditions so extreme that the very concept of solid matter becomes meaningless. So what does it mean for Jupiter to become habitable? It means reimagining life itself. It means thinking about existence not in terms of surfaces and soils and roots, but in terms of floating, of drifting, of finding the layer in that vast atmospheric column where the temperature is right and the pressure is tolerable and there is enough chemistry to sustain something alive. Jupiter becoming habitable might mean gigantic floating ecosystems, vast living structures, drifting within calm atmospheric layers above endless clouds. Communities of organisms, perhaps, that never touch a solid surface because there is no solid surface to touch, that navigate by wind and pressure gradient, that have evolved or been imagined in this quiet hypothetical to call the sky their ground. It is one of the most alien possibilities in all of this, and yet there is something deeply peaceful about it. The idea of life finding a way in a world with no edges, no boundaries, no horizon that does not simply lead to more sky. And Saturn, which lies beyond Jupiter, takes that image and extends it even further. Saturn is, to many eyes, the most beautiful planet in the solar system. Its rings, made of ice and rock, stretching out for hundreds of thousands of kilometers, are one of the most astonishing structures in the known universe. No photograph really does them justice. They are paper-thin relative to their width, delicate as a whisper, and yet grand beyond easy comprehension. Saturn's skies could contain enormous airborne cities, floating continents, suspended structures in thick, warm atmospheric zones, if its conditions were somehow stabilized for life. The rings themselves, seen from within the atmosphere, would be an extraordinary sight, curving overhead like an impossible bridge across the sky, illuminated by a sun that is almost 10 times further from Saturn than it is from Earth, casting everything in a soft, amber, late afternoon light. An airborne civilization on Saturn. Communities of people, perhaps, whose entire world is made of cloud and wind and the slow turning of enormous atmospheric vortexes, who have never seen bare rock, who navigate not with maps of terrain but with maps of pressure and temperature and the great river currents of gas that flow around the planet's equator. And then Uranus, quiet, distant, and strange. Uranus is the only planet in the solar system that rotates on its side. Its axial tilt is 98 degrees, which means it orbits the sun essentially rolling like a ball rather than spinning upright like a top. The result is the strangest seasons anywhere in the solar system. When one pole faces the sun during Uranus's long orbit, that pole experiences 84 Earth years of continuous sunlight. And then, as the planet continues around its path, the other pole takes its turn. 42 years of day, 42 years of night, cycling slowly through the eons. In a habitable Uranus, those seasons would create some of the most extraordinary experiences imaginable. There would be places on the planet where the sun spirals slowly overhead for decades before finally beginning its long, gradual descent. Where the rhythm of days and nights that living things on Earth take entirely for granted simply does not exist. Where an entire human lifetime might be lived within a single polar summer, children born in light and growing old without ever having seen the stars. And then, at last, Neptune. Neptune is the furthest planet, the one that takes the longest to orbit the sun. A Neptunian year is the equivalent of 165 Earth years. At that distance, the sun appears not as the blazing disk we know, but as a very bright star, powerful enough to read by, but small, distant, almost humble. What Neptune is not quiet about is its weather. Neptune has some of the fastest winds in the solar system, winds that currently reach speeds of over 2,000 kilometers per hour, faster than the speed of sound in Earth's atmosphere. The planet is a world of storms, of dark spots and white cloud streaks whipping around its blue-green surface at extraordinary velocity. Neptune's powerful winds would need to calm dramatically before any stable life or civilization could exist there. The transformation of Neptune into a habitable world would require the most fundamental kind of atmospheric peace. A settling of the turbulence, a quieting of those extraordinary gales, until something gentle enough for life to take root could finally emerge on one of the most remote and beautiful worlds in the solar system. And as we contemplate all of this, the terraforming and transformation of 8 planets, it is worth remembering that planets are not alone. They travel with companions. Many of the moons in the solar system, places like Europa, with its global ocean beneath a shell of ice, Titan, with its thick orange atmosphere and lakes of liquid methane, a world where the chemistry of life's building blocks falls from the sky like rain. Enceladus, a small moon of Saturn that jets water vapor into space from cracks at its south pole. These worlds might also become habitable alongside their parent planets, multiplying the number of living worlds even further, not just 8 new homes, but dozens. each with its own character, its own sky, its own particular quality of light. And finally, perhaps the most intimate change of all. If every planet became habitable, if lights began to glow across the solar system, the lights of cities, the lights of satellites, the lights of civilizations spreading across worlds that were once dark and silent, then the night sky as seen from Earth would slowly, gradually begin to change. The planets have always been beautiful. Venus glittering on the horizon, Mars burning orange in the summer sky. Jupiter is steady and bright in the dark of winter. But they have always been empty lights, points of reflected sunlight, telling us nothing about what was happening on their surfaces because nothing was happening on their surfaces. Now imagine looking up and seeing more, seeing a faint additional glow around Mars, not just sunlight but the light of something living. Watching Venus brighten slightly with the illumination of millions of lights. Finding Jupiter in the sky and knowing that somewhere in those swirling bands of cloud, life is drifting through the endless atmospheric layers, going about whatever it is that such extraordinary beings go about. The sky would not look dramatically different, not at first, but it would feel different. It would carry a different weight. The ancient human habit of looking up at the planets and feeling small and alone would be replaced by something else. Something warmer, the feeling of looking across a distance and seeing, however faintly, however impossibly, the lights of home. Not one home, many. There is something that happens when you watch a sunset, something quiet and involuntary. Whatever you were thinking about before, whatever occupied your mind, whatever felt urgent or unresolved, it tends to soften. The colors arrive slowly, or sometimes all at once, and the world shifts into a register that is harder to name. Warm, still, complete somehow in the way that endings can be complete. And for a few minutes, without really deciding to, you simply watch. Every inhabited world would have sunsets. That much seems certain. As long as a planet turns, and as long as a star shines, there will be that daily moment of transition. Light to dark, day to night, the slow or sudden departure of the sun below the edge of the world. But not every sunset would look the same, not even close. In a solar system full of habitable worlds, the sunset would become one of the most personal things a world could offer. A signature, a character, something as unique to a planet as the color of its sky or the smell of its air. And perhaps the most unusual sunsets of all would belong to the smallest planet, the one closest to the sun, the one that, in our imagining, has been given the gift of an atmosphere and oceans and breathable air against all the odds of its location. Mercury. A habitable Mercury would offer the fastest sunsets in the solar system, or at least, in certain places, something even stranger than a fast sunset. Near the poles of Mercury, the sun would not set in the way we think of setting. It would not simply sink below the horizon and disappear. Because of Mercury's slow rotation and its eccentric, elongated orbit around the sun, and because of the particular geometry of where the poles sit relative to that orbit, there would be places where the sun appears to hover, where it slides along the horizon rather than descending below it, where it drifts, almost lazily, from one point on the edge of the world to another, barely dipping, never fully leaving. Imagine sitting on the rocky shores of a Mercurian sea, near one of its poles, watching that enormous sun hang at the edge of everything, not rising, not setting, just present at the horizon. The sky above shading from deep black at the zenith down through blues and violets and reds to an intense orange glow where the sun sits, vast and still. The light would be extraordinary. The shadows would be long and theatrical, stretching across the landscape in every direction, turning every rock and ripple of water into something dramatic. And it would last. That twilight, that hovering in-between state would go on for hours. For any civilization that grew up on Mercury, the horizon would be a sacred thing, the place where the sun lived. And that sun, seen from Mercury, would be unlike any sun ever witnessed from Earth. Because Mercury orbits so close to the sun, travelers there would witness the sun appearing much larger in the sky than it does from Earth. Nearly 3 times larger, almost 3 times the angular width, which means, standing on a Mercurian beach, looking up at midday, you would not see the familiar compact disk of our star, the one you can just barely cover with your outstretched thumb, but something overwhelming. Something that fills the sky in a way that feels more like a presence than an object. From Earth, we have all grown up with a particular intuition about the sun. We know not to look at it directly. We know it is the source of light and warmth, but it is also somehow manageable, distant enough to be safely in the background of our experience. On Mercury, that distance is dramatically reduced, and the sun would be impossible to ignore in a different way than it is on Earth. Not dangerous in this imagined habitable version, but dominant, magnificent, constant, enormous companion in the sky. People who grew up on Mercury would probably have a different relationship with the sun than any other human beings in history. It would not be a star to them. It would be something almost geological, something the landscape was organized around. Now let us drift outward, from Mercury, past the darkness between worlds, to Venus, to those blue skies and those shallow tropical seas that we imagined in the last act. Close your eyes and arrive there at evening. Venusian oceans might glow orange during sunset, not because of any bioluminescence or strange chemistry of the water itself, but because of what the light does as it passes through that atmosphere. Venus, even in its transformed, habitable state, would still have a thicker atmosphere than Earth. The planet's gravity and its history would likely mean more air overhead, more density, more layers for sunlight to travel through before it reaches the surface. And the more atmosphere light passes through, the shorter blue wavelengths scatter away, and the longer red and orange wavelengths remain. On Earth, this is what gives us red sunsets. When the sun is low on the horizon, its light passes through more atmosphere than when it is overhead, and the sky turns those warm evening colors we know so well. On Venus, with its thicker air, this effect would be magnified, prolonged. The entire transition from afternoon to evening would be bathed in orange and amber tones that Earth's sunsets can only briefly approximate. And the light falling on the water would take on that color. The ocean would hold the skies orange in its surface, shimmering and shifting as the waves moved. From the shore, looking out across a Venusian sea in the hour before dark, the entire world would seem to be made of warm light. The sky, the water, the wet sand, the leaves of whatever plants had taken root along the coast, all of it drenched in a deep, amber glow that Earth could not quite replicate, because Earth does not have quite the atmosphere for it. It would be one of the most beautiful things in the solar system. And the rains. Let us spend a moment with the rains of Venus. On a fully habitable Venus, thick clouds could create long, gentle rainstorms lasting for days across warm tropical landscapes. Days, not the brief afternoon thunderstorms of Earth's tropics, nor the short, intense squalls that blow through coastal towns and are gone before you can put away your umbrella. But long, sustained, patient rains. The kind that settle in and become part of the rhythm of a week. That turn the air soft and heavy and fragrant. That fill every hollow with running water and leave the landscape looking polished and new when they finally pass. Because Venus is closer to the sun than Earth, and because even a habitable Venus would likely retain a dense and moisture-laden atmosphere, the water cycle would be energetic. Evaporation from those shallow tropical seas would be constant and generous. Water vapor would rise and cool and condense, forming clouds that are thick and persistent. And when those clouds finally released their rain, they would do so with a thoroughness that Earth's tropics might envy. Imagine being in a forest on Venus during one of those rains. the canopy above, whatever strange and lovely trees had grown there, adapted to Venusian light and Venusian gravity, would be alive with the sound of water. Not the roar of a downpour, but the sustained, layered music of rain falling on 10,000 leaves simultaneously, each drop catching and redirecting the sound in its own small way until the whole forest hums with it. The ground would be warm and damp and alive. The air would smell of earth and growth, and it would go on and on and on through the long Venusian day. There is a particular peace to being in a warm place during a long rain. The sense that the world has given itself permission to slow down, that the ordinary urgency of things has been suspended, and all that is required is to be still and listen. A Venusian rainstorm would offer that feeling in abundance. And then, stepping outward once more, we arrive at Mars, where the weather tells a very different story. On Mars, even in this imagined habitable version, the past would not entirely release its grip, because the dust is still there. The iron-rich, fine-grained dust that covers vast stretches of the Martian surface and gives the planet its characteristic red-orange color. That dust can be lifted by wind, and once lifted, it does not come down quickly. The Martian atmosphere, even in a habitable state, would likely be thinner than Earth's, which means dust, once suspended, can stay suspended for a very long time. Mars dust storms could still happen for weeks at a time, even in our imagined future version of the planet, turning entire continents into dim reddish fog beneath a cold sun. Not the biblical disaster they might sound like, perhaps, but one of the defining experiences of Martian life, something to be prepared for, to shelter through, to wait out with patience. Think about what a Martian dust storm would actually look like from inside. The sun, already smaller and cooler than Earth's sun, would be further dimmed. The sky, which on a clear Martian day might be a pale butterscotch color, would deepen into something darker and more uniform. A reddish haze that erased the horizon, that turned the middle distance into a vague amber murk, that reduced visibility to kilometers, then hundreds of meters, then less. The wind would carry the dust against every surface, coating everything in that fine, rust-colored powder. But there would be beauty in it too. The diffused, reddish light of a dust storm is gentle in its way. Everything seen through it has soft edges. The landscape becomes impressionistic, layered in amber gauze. And when the storm finally lifts, when the wind drops and the dust begins to settle slowly over hours and days, returning to the surface it came from, the air would clear from the top down, and there would be a moment when you could look up and see the sun again, still faint, still filtered, but present, warm and distant and returning. The Martian sky at night, however, is perhaps where the most intimate and moving of all Martian experiences would occur. The night skies on Mars might appear especially dramatic, and perhaps the most affecting sight of all would be one small blue star visible to the naked eye. Not just any blue star. Earth, our world, seen from the red world, as a point of light in the Martian night. Bright enough to cast a faint shadow on a cloudless night. Blue in a way that would be unmistakable and strange to any eye accustomed to looking up at a sky where blue means daytime, where blue means sky, not stars. There is something deeply affecting about the idea of standing on Mars at night and looking back. We have the famous photograph taken by the Voyager 1 spacecraft, long after it left the solar system, in which Carl Sagan asked the mission team to turn the camera around, to take one last picture of home. And there, in that photograph, across a vast distance, is Earth, a tiny, pale blue dot, small enough to be covered by the head of a pin. From Mars, it would be larger than that, brighter, but the essential feeling would be the same. The recognition that home is a point of light, that all of human history, all of its art and war and love and hunger and tenderness and cruelty and achievement, happened on that small, bright, blue-white speck in the darkness. Standing on a habitable Mars and looking at Earth would be one of the most philosophical moments a person could have. Whatever questions they had arrived with, they would leave with more. Now let us drift much further. Past the asteroid belt, past the familiar rocky worlds, out into the realm of the giants. Jupiter and Saturn. Worlds of cloud and storm and scale are so immense they change the way you think about the word large. And in these worlds, if life were to exist at all, it would have to exist in a form that we might not immediately recognize as life. Because there is no ground to stand on, no surface to root into, no bottom to the world that any reasonable creature could reach. Life on a gas giant, if it existed, would have to be something that had made peace with the sky. Floating life forms on Jupiter or Saturn might evolve something like enormous airborne jellyfish. That is one way to imagine them. Creatures that drift through the dense cloud layers, carried by powerful winds, trailing long tendrils through the chemistry of the atmosphere. Not swimming exactly, but something in between swimming and flying. Moving through a medium that is neither entirely gas nor entirely liquid, that shifts and changes with altitude and temperature and pressure. The jellyfish comparison is useful because jellyfish here on Earth are ancient. They are some of the oldest multicellular animals on the planet, organisms that have been drifting through the oceans for more than 500 million years without the benefit of a brain or a backbone or any of the biological complexity we usually associate with successful life. They have survived every mass extinction. They are, in their quiet and boneless way, extraordinarily resilient. Life on Jupiter might be like that. Patient, passive, suited to a world where the rules are different, where the advantage goes not to the swift or the strong but to whatever can maintain its altitude in a changing atmosphere. Whatever can extract what it needs from the chemistry of clouds. Whatever can ride the winds without being destroyed by them. And those winds would be part of the habitat, not just a hazard to be endured. The great banding of Jupiter's atmosphere, those alternating belts and zones of different temperatures and compositions that create the gorgeous striped appearance we know from photographs. Those represent different ecological zones. Different neighborhoods, if you want to think of it that way, each with its own chemistry, its own temperature, its own particular character. Habitable gas giants might contain layers of floating ecosystems stacked high above one another, each surviving at different altitudes and pressures, like floors in an enormous building that has no roof and no foundation. At one altitude, the temperature might be comparable to a warm spring day on Earth, and the pressure might be similar enough to what we know for something like life to thrive. 1,000 kilometers below that, conditions would be entirely different, hotter, denser, stranger, and 1,000 kilometers above, thinner, colder, bathed in radiation from the sun. Each layer is a separate world. Each layer, perhaps, a separate biosphere. The beings of the upper layers might never encounter the beings of the lower layers. The distance between them, in terms of pressure and temperature and atmospheric composition, would be as significant as the distance between the deep ocean floor and the high mountain peaks of Earth. Separate environments, separate chemistries, separate forms of life that might look at each other, if they could look at each other at all, with the same bafflement we feel when contemplating creatures from an entirely different ecosystem. And there is one more feature of life on the gas giants that deserves its own quiet moment of consideration. The storms. On Jupiter, as we noted, the Great Red Spot has persisted for centuries. A storm larger than Earth, swirling and ancient, a structure in the atmosphere so stable that it has outlasted entire human civilizations. If Jupiter were habitable, that storm would not simply be a meteorological curiosity. It would be a landmark, a geographical feature as significant, in the minds of any beings who lived there, as a mountain range or a continent. Habitable gas giants could produce permanent storms that become famous landmarks, similar to continents or oceans on Earth. Think about that for a moment. Not just that storms could be famous, but that they could serve the same organizing function in the lives of gas giant inhabitants that landmasses serve in ours. Our maps are defined by continents. Our identities, in many ways, are shaped by the particular piece of land our civilization developed on. For the beings of a gas giant, the great storms would play that role. The permanent structures of the atmosphere, the things that stay when everything else shifts. A storm you could navigate by. A storm that had a name, that appeared on maps, that sailors, or whatever the atmospheric equivalent of sailors might be, used as a reference point on long journeys across the cloud ocean. A storm that had been there when the first generation of beings began to understand their world, and would still be there when the last generation looked up at the sky and wondered what lay on the other side of it. There is something both humbling and wondrous about that image. These enormous, ancient, churning structures of wind and chemistry, becoming the mountains of another world's imagination. And finally, at the edge of all of this, Neptune. Of all the habitable worlds we have imagined, Neptune might be the one that most rewards quiet contemplation. Because it is the furthest. Because the sun, as seen from Neptune, gives barely a fraction of the warmth and light it gives to Earth. Because at that distance, even time seems to move differently, a Neptunian year lasting longer than a century and a half. Neptune is a world of deep blues, of extraordinary distances, of a particular quality of light that does not exist anywhere closer to the sun. A habitable Neptune could have deep blue oceans, real oceans, water vast and cold, illuminated by the faint sunlight that reaches that far into the solar system. And in that faint light, Neptune's oceans would be unlike any other ocean in the solar system. On Earth, the deep ocean is dark. Sunlight penetrates only the uppermost layers, the first 200 meters or so, and below that, the world is perpetual night. On Neptune, the faintness of the sun would mean that even the surface waters would be illuminated softly, dimly, in that particular blue that exists when light is present but not abundant. Not darkness, but something close to it. The blue of deep water under an overcast sky, extending in every direction, all the way to a horizon that is slightly further away than Earth's horizon, because Neptune is a larger world, creating one of the darkest natural seascapes in the solar system. Not menacing darkness, not the darkness of something absent, but the darkness of distance, of depth, of a world that exists at the edge of what the sun can comfortably reach. A world that has learned to live on a little less light than most. There would be something extraordinarily peaceful about Neptune's oceans. The quality of the light, the particular cold blue of everything, the faint presence of the sun, small and still bright enough to illuminate the world, but distant enough that its light arrives as a suggestion rather than a command. And above those deep blue waters, a sky that would shift from deep violet at the zenith to something lighter near the horizon, where the faint warmth of the distant sun would color the edge of the world in the softest oranges and golds. Neptune would be quiet in a way that the inner planets could not be. Quiet with distance. Quiet with the patience of a world that takes 165 years to complete a single orbit, that measures time in a scale so much larger than a human life that the very concept of urgency would seem slightly absurd there. In all of these worlds, in all of these extraordinary and varied imaginings, there is a pattern. Life does not require a single set of conditions. It does not insist on one type of sky, or one distance from the sun, or one kind of landscape. Given the opportunity, given the right circumstances, the universe finds a way to fill the available space with something. Something that breathes or drifts or roots or swims. Something that perceives its world and responds to it. In this imagined solar system of habitable worlds, that filling in would happen everywhere at once. Mercury with its hovering sun and its pole-side twilights. Venus with its amber oceans and its patient, soaking rains. Mars with its dust-reddened skies and its blue evening star. Jupiter and Saturn with their stacked atmospheres and their famous storms. Neptune with its dark, blue seascapes and its faint, soft light. Each world is different. Each world is complete. Each world, in its own way, is home. And the universe, which had seemed for so long to be mostly empty, would reveal itself to be mostly alive. Of all the things that make a world feel like a world, perhaps none is more immediate than the sky. Not the ground beneath your feet, though that matters too. Not the temperature of the air or the smell of it, or the way the wind moves through whatever grows there. Those things take time to notice. They accumulate gradually as you move through a place, building into an impression. But the sky is instant. You look up, and the sky tells you everything about where you are. Its color, its depth, the size and brightness of the sun, the presence or absence of clouds, the way light behaves as it moves through whatever atmosphere wraps this particular world. All of it arrives in a single glance. Before you have taken your second breath, you already know. This is not Earth. In a solar system full of habitable worlds, the sky would be the great differentiator. The thing that made each world unmistakably itself. A traveler moving from planet to planet, from moon to moon, could close their eyes between arrivals and open them to the sky and know immediately, without any other information, which world they had come to. Because no two skies, in this extraordinary imagined solar system, would be the same. Not even close. Let us begin with one of the most gently beautiful of them all. Uranus, that quiet, tilted, distant world that we touched on briefly before, the world that rolls through its long orbit like a ball rather than spinning like a top. If Uranus were habitable, its sky would carry a color unlike any sky on any other world in the solar system. A soft, natural blue-green, not quite the blue of Earth's sky, not quite the blue of Neptune's. Something in between. Something that feels simultaneously familiar and entirely alien. A habitable Uranus could have oceans and clouds tinted slightly turquoise because of the gases naturally present in its atmosphere. The methane that exists in Uranus's upper atmosphere absorbs red light and reflects blue and green wavelengths back into space. It is the reason Uranus appears the color it does in photographs. That pale, almost mint green, so different from the warm oranges and tans of the gas giants closer to the sun. In a habitable version of the planet, that underlying chemistry would still be present. The sky would carry it. The water would hold it. Even the clouds, drifting through that turquoise air, would have a slightly greenish cast, as if the entire world had been lit from within by something soft and aquatic. There is a particular quality of light that exists in shallow tropical water here on Earth. When you are swimming in a clear, sunlit sea over a pale sandy bottom, the light around you turns a blue-green that seems almost luminous, as if the water itself is producing the light rather than simply transmitting it. A habitable Uranus might feel something like that, as if you were permanently inside that beautiful submerged light, as if the world itself were made of it. The oceans of Uranus, in this imagining, would be extraordinary to behold. Not just because of their size, though they could be vast, but because of the color they would take from that methane-rich atmosphere above. A turquoise sea beneath a turquoise sky, with clouds that shade toward green at their edges and toward white at their centers, and a sun that hangs in that sky at its peculiar angle, neither directly overhead nor quite where any earth-born intuition would expect it to be. It would be one of the most consistently, quietly beautiful environments in the solar system. A world that seemed to have settled on a single color and committed to it completely. And then, moving to a world that is in some ways even more alien, even more unlike anything our earthbound experience has prepared us for, let us visit one of the most discussed and fascinating moons in the solar system. Titan, that thick atmosphered, orange-skied moon of Saturn, the only moon in the solar system with a dense atmosphere of its own, the only place other than Earth where liquid has been found pooling on a surface. In the real solar system, Titan's liquids are not water. They are methane and ethane, hydrocarbons that remain liquid in Titan's extraordinary cold. But in our imagination, a habitable Titan is a warmer, more welcoming place. A place where water flows, where something like weather operates, and where the thick, golden atmosphere does something remarkable. On a habitable Titan, people could witness rain falling slowly through thick golden skies, with the atmosphere dense enough to make flying easier than on Earth. Think about that second part for a moment. Titan's real atmosphere is approximately 4 times denser than Earth's. A thick, hazy, golden-orange blanket of mostly nitrogen, heavy enough that if you held out your arms and ran, you might feel genuine lift. In a habitable Titan with conditions adjusted for life, that density would remain. The air would be rich and thick, and in that rich, thick air, falling raindrops would behave differently than they do on Earth. They would fall more slowly, drifting down through that heavy golden atmosphere with a kind of languor, a dreamlike patience, as if they were not quite sure they were in a hurry to arrive. Watch rain fall on a still day here on Earth, and there is already something hypnotic about it. The randomness of it, the way each drop catches light for an instant before disappearing into the ground. Now imagine that same rain slowed. Each drop spent more time in the air, more time catching that thick golden Titan light, which has passed through layers of haze to become something amber and warm and diffused, with no hard shadows, nothing sharp. Just soft, all-directional light the color of late afternoon, falling through air thick enough to swim in, as the rain drifts slowly down. And above that rain, above those golden clouds, the sky of Titan would have a particular quality of its own. Opaque in a way that Earth's sky never quite is. You would not see stars through it even at night. You might not be entirely sure on a cloudy day exactly where the sun was. The light would come from everywhere and nowhere, filtered and softened by layers of organic haze until it arrived at the surface as that warm, pervasive glow. A world without hard edges. A world that seemed to exist in a perpetual, comfortable dusk. And yet somewhere above all that haze, if you could rise high enough, above the clouds and the golden murk, you would find something extraordinary waiting for you. Because Titan orbits Saturn. And Saturn, even from that distance, even through the cleared air of altitude, would be enormous. Which brings us to one of the grandest features of life in the outer solar system. Habitable moons orbiting giant planets might experience glowing nights, lit not only by stars, but also by the reflected light of enormous nearby worlds. On a moon like Titan or a habitable Enceladus or a transformed Europa, the night sky would be dominated not by the moon the way our moon dominates Earth's night sky, but by the planet itself. By Saturn or Jupiter, looming immense and brilliant, reflecting sunlight down onto its moons with a generosity that our own moon cannot match. Consider Saturn seen from a habitable moon in its system. Saturn is roughly 10 times the diameter of Earth. Seen from within its moon system, it would fill a portion of the sky that no object in Earth's sky, save the sun itself, comes close to occupying. It would be present, not just there in the way the moon is there, noted, beautiful, useful for navigation and tides, but genuinely, overwhelmingly present. A world so large that it defines the sky around it. On nights when Saturn was well placed and the haze was thin, its reflected light might cast shadows. Soft, diffused shadows, nothing like the sharp shadows of bright sunlight, but real shadows nonetheless, evidence that this light has direction, that it comes from somewhere specific, from that vast ringed presence overhead. The rings, we have mentioned them before, but they deserve their own moment here. Saturn's rings would become one of the most breathtaking sights in the solar system, appearing as glowing arcs stretching across huge portions of the sky from any habitable moon within the ring system's neighborhood. Imagine lying on your back on the warm ground of a Titan meadow, or whatever Titan's equivalent of a meadow might be, and looking straight up. The sky above you is golden and hazy near the horizon, But higher up, where the atmosphere thins, you begin to see through it. And there, curving from one side of the sky to the other, in a great sweeping arc that follows a geometry so perfect it seems impossible, are the rings. Not rings as you see them in photographs, viewed from a distance, appearing as a flat disk around Saturn, but rings seen edge-on or at angle from a position within or near the ring plane, appearing as a line of extraordinary brightness, a glowing band across the sky, catching sunlight along their length and scattering it in all directions. Ice and rock, hundreds of thousands of kilometers wide and yet paper-thin relative to that width, illuminated from the side by a sun that is small but still powerful enough to make them blaze. There would be places on a habitable Titan where the rings would appear to rise from the horizon on one side, arc overhead, and descend to the horizon on the other. Permanent rainbow, a permanent bridge across the sky, present every clear night and every clear day, unmoving while everything else rotates around it. The most consistent and reliable feature of the entire heavens. Any civilization that grew up on a moon of Saturn would build its mythology around those rings. Its architecture would reference them. Its art would be saturated with that particular arc, that clean, perfect curve. The rings would be the organizing image of an entire culture, the way the horizon organizes ours. But the sky of a Saturn moon would offer more than just beauty. It would offer drama, specifically the drama of eclipses. On distant habitable moons, eclipses could become common events, with enormous planets regularly blocking sunlight and darkening the skies. Not the rare, breathtaking, once-in-a-generation events that solar eclipses are on Earth. Those brief minutes when the moon slides precisely across the sun and the day turns to twilight and every animal and every plant seems to hold its breath. On the moons of the gas giants, eclipses would be regular, predictable, a feature of the calendar rather than an entry in the history books. When Jupiter or Saturn passed between a moon and the sun, the sky on that moon would darken. Not to night, not entirely, but to something in between. A deep, unusual twilight, with the stars becoming visible in the middle of the day, and the planet itself glowing in front of where the sun had been, lit from behind by a corona of refracted light. Aurora would likely erupt during these events as the magnetic fields of the giant planets interacted with the sudden change in solar wind. The sky would come alive with color just as the sun disappeared. And then the sun would return, sliding out from behind the planet's limb, and the day would warm again, and the stars would fade, and life would continue its ordinary business. For any moon dweller, an eclipse would be something you planned your week around. Not with fear, not with the ancient terror our ancestors felt at unexpected darkening of the sky, but with anticipation. Something to watch, something to sit outside for with people you care about, looking up together at one of the most extraordinary regular performances in the solar system. Now let us make the long journey outward, all the way to the edge of what we normally consider the solar system, and slightly beyond it, to a world that is no longer classified as a planet but that carries, in the imagination, a particular kind of emotional weight. Pluto. Small, distant, cold, and for decades beloved. The planet that lost its planetary status but never lost its place in the human heart. A world of nitrogen ice, of mountains made of water ice and coated in frozen methane, of a thin atmosphere that briefly thickens when Pluto's elliptical orbit brings it slightly closer to the sun and then collapses back into frost as it recedes. A world that receives so little sunlight that midday on Pluto is darker than twilight on Earth. A habitable Pluto could have vast frozen forests and dim icy mountains glowing faintly beneath distant sunlight. This is perhaps the most delicate and melancholy of all the habitable worlds we are imagining. Because Pluto, even made habitable, would be quiet in a way that the other worlds would not be. The sun, from Pluto, is roughly 40 times further than it is from Earth. It is a star, the brightest star, certainly still powerful enough to cast light and provide some warmth, but unmistakably a star rather than a disk. You could look at it directly, almost. It would be extraordinary, but not blinding. In that star-like sunlight, everything on Pluto would glow rather than shine. The ice mountains, and Pluto has real mountains, ranges of water ice that rise 3,000 meters above the surrounding plains, would catch the light and hold it differently than rock does. Ice has a quality that stone does not. It translates light rather than simply reflecting it, giving it a depth, a quality of coming from within. In Pluto's faint sunlight, those icy mountains would glow, softly, as if lit from inside by something gentle and cold. And the frozen forests, what would they be? Trees adapted to extreme cold and extreme dimness would be very strange trees. Perhaps slow-growing almost beyond imagining, because there is so little energy available in that faint sunlight. Perhaps dark, almost black, to absorb every available photon. Perhaps wide-branched and low, spread out to catch as much of that precious dim light as possible. They would grow in valleys where any marginal warmth might accumulate, along the shores of whatever liquid water could persist in that cold. And they would be still in that thin Plutonian air because wind at Pluto would be barely a breath. Standing in a frozen Plutonian forest, surrounded by those dark, slow trees, with the icy mountains glowing beyond them and the sky overhead black and full of stars. Real stars, visible even in the middle of the day because the sun is not bright enough to wash them out, would be one of the most singular, contemplative experiences in the solar system. Not dramatic, not overwhelming, just deeply, quietly beautiful. A world that asked nothing of you except that you be still and pay attention. And speaking of stars visible in the daytime sky, let us consider what light means to a world, and how differently it behaves depending on where in the solar system you find yourself. People living on Neptune might see the sun as only a very bright star, giving their daytime skies a dim twilight feeling compared to Earth. We touched on this before, but it is worth sitting with more fully, because it means something profound about what life on Neptune would feel like from the inside. Daytime on Neptune would not be what we mean by daytime. It would be something more like a very clear dusk. The sky would be illuminated, genuinely illuminated, bright enough to work and move and live by. But the source of that illumination would be a star-sized point, not a disk. And the sky would retain its darkness in a way that Earth's sky never does during the day. Stars would be visible in Neptune's daytime sky. The brighter ones, at least, faint at first near the horizon, but there. And the whole sky would have a depth to it, a three-dimensionality that Earth's daytime sky lacks. Here, during the day, the blue of the sky fills everything and the stars disappear behind it. On Neptune, the day would never quite manage that. The universe would always be visible, just behind the thin veil of a sun too distant to fully hide it. For Neptune's people, there would be no sharp division between day and night in the psychological sense. The stars would always be present, always available. The night would simply be the time when that one bright star, the sun, went below the horizon, and the stars that had been faint and secondary all day became the primary lights of the world. It would be a sky that kept you humble, a sky that reminded you, every hour of every day, that you were in the universe, not separate from it. And in that universe, Neptune's powerful magnetic field would interact with the thin stream of charged particles that reaches even that far from the sun. The auroras on Neptune would be spectacular. Habitable planets farther from the sun might see spectacular auroras almost every night, as those magnetic fields sweep up solar particles and channel them toward the poles, where they collide with the upper atmosphere and release their energy as light. On Earth, auroras are celebrated, photographed, and traveled thousands of kilometers to witness. They appear most reliably in narrow bands near the poles, and even there they are not guaranteed on any given night. But on Neptune, on Uranus, on worlds with powerful magnetic fields at the edges of the solar system, auroras would be a nightly feature. As reliable as the sunset. After the sun went below the horizon and the sky deepened into its full nighttime darkness, the poles would begin to glow. Greens and blues and violets, rippling and shifting with a slow, breathing quality. Curtains of light in colors that seem too vivid to be natural, dancing with a patience and a grandeur that takes the breath away every time, even if you have seen it 10,000 times before. Now consider the opposite end of the solar system. Mercury and Venus, close to the sun, bathed in light far more intense than anything that reaches the outer worlds, where the sky during the day would be brilliant, blazing, light so abundant that the stars are not merely hidden but completely overwhelmed. Habitable planets closer to the sun would likely have brighter daytime skies, making stars almost impossible to see without advanced observatories. On Mercury, during the day, the sky would be a white so intense it would be painful to look at near the sun. On Venus, beneath its layers of cloud, the diffused brightness would be extraordinary in its own way. Light coming from everywhere, no shadows, no directional quality, just a pervasive, warm, orange-tinted brilliance. These would be worlds where the stars were something you waited for, where nightfall was an event, an arrival, a gift. The patience required to wait for dark on a slow-rotating Mercury, where the day lasts 58 Earth days, would give that eventual nightfall an extraordinary weight. When the sun finally disappeared below the horizon after weeks of its overwhelming presence, and the first stars began to appear, and then more stars, and then the full darkness settled in and the Milky Way revealed itself overhead, that moment, after so long a wait, would feel like a revelation every time. And somewhere between those two extremes, between the blazing closeness of the inner worlds and the dim, star-soaked quiet of the outer ones, is Earth, our world. The one we were born to, the one whose sky we know so intimately that we rarely stop to appreciate what a particular and specific thing it is. That particular shade of blue, that comfortable, moderate sun, those nights that come with reliable regularity, neither 58 days late nor confusingly indistinguishable from the day. A person who traveled through this imagined solar system, visiting several habitable planets in the course of a single human lifetime, would experience entirely different skies at every stop. Some worlds with giant rings curving overhead. Some with multiple moons casting overlapping shadows on the ground below. Some with the dim, distant softened light of a sun that is more star than disk. Some with turquoise oceans and golden rains and storms large enough to be continents. Some with auroras every night and some with skies so bright you could not see a single star at noon. And returning, after all of that, to Earth, to our blue sky and our one moon and our familiar sun, might be the strangest moment of all, because you would see it differently. The sky above you, the one you grew up under, the one that you stopped noticing because it was always there, would suddenly be visible again. Really visible, the way it was when you were a child and the world was still strange and every sky was something to look at. You would notice the blue, the specific, particular blue that is Earth's alone, produced by the way our nitrogen-oxygen atmosphere scatters the light of our specific sun from our specific distance. You would notice the clouds, the way the light falls, the softness of an afternoon, the way the stars come out at night, dependable and ancient and perfectly proportioned for human eyes. You would notice that you were home. In a solar system of extraordinary skies, Earth's sky would still be yours, and it would feel, after all of those other worlds, like the most extraordinary sky of all. Not because it is the most dramatic, not because it is the most colorful or the most unusual or the most filled with wonders, but because it is the one that made you. The one that looked back at you from your very first moment and quietly, without fanfare, welcomed you into the universe. There is a thought experiment that biologists sometimes use when they want to illustrate just how improbable, and yet how inevitable life seems to be. They ask you to imagine rewinding the history of Earth, all the way back to the beginning, to the first simple molecules that gathered in the warm, shallow water of an ancient sea and began, for reasons we still do not fully understand, to organize themselves into something that could copy itself. And then they ask, if you let it run again, from exactly that same starting point, would you get the same result? Would you get jellyfish and oak trees and elephants and hummingbirds? Would you get anything like us? The answer, most biologists believe, is almost certainly no. Not exactly. Perhaps not even close. Life's history on Earth is so dependent on chance, on the particular asteroid that struck, the particular ice age that came, the particular mutation that happened in the particular organism at the particular moment, that running the experiment again would almost certainly produce something different. Not nothing. Life, once it starts, seems to find ways to persist and diversify. But a different life. Life is shaped by different accidents, taking different directions, filling the available space in ways we could not predict in advance. Now take that thought experiment and expand it to an entire solar system. 8 planets, dozens of moons, each one with its own gravity, its own atmosphere, its own distance from the sun, its own chemistry, its own particular history of chance and contingency. Each one, in our imagining, now habitable, now alive with the possibility of ecosystems, of food chains, of the slow and patient work of evolution shaping living things to fit the particular demands of their particular world. What would grow there? Each planet would likely develop its own unique wildlife, adapted to local gravity, atmosphere, and climate, creating ecosystems unlike anything found on Earth. That sentence is simple enough to read quickly, but it contains within it something almost limitless. Because the space of possible living things, the range of forms that life can take when the conditions change, is not a small space. It is not a list you could write down or a gallery you could walk through in an afternoon. It is enormous, perhaps infinite. Let us begin with something fundamental, something that shapes the possibilities of life on any world more than almost any other single factor. Gravity. Gravity is the quiet ruler of biology. Here on Earth, it sets the terms for almost everything. How tall a tree can grow before it can no longer pump water to its own highest branches. How large an animal can be before its skeleton collapses under its own weight. How birds must be shaped and proportioned to generate enough lift to overcome their own mass. Gravity is the constant negotiation that every living thing on Earth has learned to work within, and most of the time we do not think about it because we have never experienced anything different. But the planets of the solar system do not all have the same gravity. Mars has about 38% of Earth's surface gravity. The Moon has about 17%. A large moon like Titan or Ganymede would have less than Earth but more than the Moon. And in these lower gravity worlds, in our imagination, the negotiation between life and the pull of the ground would go very differently. On worlds with weaker gravity, birds or flying creatures could evolve enormous wingspans and glide through the skies with very little effort. Think about what that means for a moment. Here on Earth, the largest flying birds, the wandering albatross, the Andean condor, have wingspans that reach 3.5 meters. These are the practical limits that Earth's gravity imposes. To go larger would require a heavier body, and a heavier body would require even larger wings, and the engineering problem eventually becomes unsolvable in the context of our particular gravitational field. On Mars, that equation shifts dramatically. A flying creature that would be grounded on Earth by its own weight might soar effortlessly on Mars, lifted by wings that need to generate only a fraction of the force required here. And so Mars, in this imagining, might develop flying creatures of extraordinary size. Creatures with wingspans that no Earth bird has ever achieved. Perhaps creatures that spend their entire lives in the air, landing rarely or never, catching rising thermals in the thin Martian atmosphere and riding them for days without effort, like living kites, patient and vast, drifting over the forests and rivers of the red world below. And below those enormous flyers, those forests, some worlds might develop giant forests stretching for thousands of kilometers, if stable climates and lower gravity allow plants to grow much larger than on Earth. On Earth, the tallest trees, the coast redwoods of California, reach about 115 meters. This is again a gravity-limited achievement. The tree must pump water from its roots to its crown against the pull of Earth's gravity. And at a certain height, the physics of water transport simply cannot manage it. The tree cannot get taller than physics allows. In lower gravity, that limit rises substantially. A tree on Mars might grow to heights that would seem fantastical by Earth standards. 200 meters, 300, perhaps more. A forest of such trees would be something beyond anything our eyes are calibrated to process. You would walk into it and immediately lose all ordinary sense of scale. The trunks rising around you, each one enormous and ancient. The canopy so far overhead that on a hazy day you might not be able to see it at all. Light filtering down from a great height, arriving at the forest floor already changed by its long journey through millions of leaves, soft and green and directionless. And those leaves might be the most visually striking thing of all, because the light on other worlds is not quite the same light as on Earth. Scientists would study how plants adapt to different colors and strengths of sunlight, possibly creating forests with leaves of unfamiliar shades. On Earth, plants are green because they have evolved to absorb red and blue light, the most abundant wavelengths in our sun spectrum at Earth's surface, and reflect the green wavelengths they cannot use. That reflected green is what we see. But on other worlds, with different atmospheres filtering the light differently, the optimal strategy for a photosynthesizing organism might be different. The wavelengths most available might be different. And the color of the leaves, the color of the forests would be different too. Dark red leaves. Not the autumn red of deciduous trees losing their chlorophyll, but a deep, permanent photosynthetic red, evolved to absorb the particular quality of light that filters through a thick Venusian atmosphere or reaches a world at a different distance from the sun. Silver leaves, perhaps, on worlds where the sunlight is so intense that a certain amount of it must be reflected away to prevent overheating. Black leaves on the dim outer worlds, evolved to absorb every available photon from a sun that is barely more than a bright star. Walk through a forest with black leaves under a purple sky, and the most fundamental visual experience of what it means to be in a forest would be preserved. The sense of being enclosed and sheltered by growing things, the sound of wind moving through the canopy, the smell of soil and life, and yet everything would be unmistakably, irreducibly alien. And the organisms that would make their lives in those forests, the creatures that would evolve to eat the leaves, or the insects that pollinated the flowers, or the things that lived in the soil and broke down the fallen matter into nutrients that the roots could drink. All of it would be unique, all of it shaped by local gravity and local light and local temperature and local chemistry, into forms that no Earth biologist could have predicted in advance, and yet that any Earth biologist would recognize immediately as alive. Life. Now consider how human beings in this imagined solar system would relate to those alien ecosystems. Not just as observers, not just as scientists or tourists, but as farmers. As the people responsible for feeding populations living on worlds where the native ecology, however extraordinary, might not provide everything a human body needs. Farming would vary dramatically across the solar system. On some planets, in low gravity and with ample light, crops might be grown at scales impossible on Earth. Fields of enormous low-gravity plants, varieties specifically bred or engineered to thrive in Martian or lunar conditions, producing yields per hectare that Earth's farmers could only dream of. A single Martian wheat stalk in the right conditions might be as tall as a tree on Earth. The logistics of harvesting it would require entirely new technologies, new machines, new approaches to agriculture that have never been needed before. And on colder worlds, farther from the sun, farming would take on an entirely different character. On the habitable but dim outer worlds, where sunlight is a precious and limited resource, agriculture might retreat indoors, into glowing ecosystems, vast, artificially lit growing chambers where the spectrum of light is precisely tuned to what plants need, where temperature and humidity are managed with care, where the entire concept of a field or a farm as an open outdoor space gives way to something more like a garden under glass, but at planetary scale. These indoor ecosystems might become some of the most beautiful spaces on the outer worlds. Warm and green and fragrant in worlds that are otherwise cold and dim, lit from within by the particular warm spectrum of growth lights. Every square meter used with the efficiency that scarce resources demand. The people who tended them might develop an intimacy with their plants and their soils that outdoor farmers never quite achieve, because when growing space is precious, you pay attention to every centimeter of it. Now let us descend deeper, below the surfaces and the forests and the farming fields into the water. The outer planets, in this imagining, could host enormous bodies of water hidden beneath warm atmospheric layers, creating marine ecosystems unlike anything in Earth's seas. This idea is not as strange as it might first appear. Even in the real solar system, Europa, a moon of Jupiter, is believed to harbor a global ocean beneath its icy shell, kept liquid by the tidal heating generated by Jupiter's gravity flexing the moon's interior. Enceladus, a moon of Saturn, jets water vapor into space from an ocean beneath its crust. The outer solar system already has water. In a habitable scenario, it might have it in abundance. What would live in those oceans? An ocean on a gas giant's moon, or in the lower atmospheric layers of a transformed giant planet, would be an ocean with different chemistry than Earth's oceans. Different mineral content, different temperature gradients, different pressure at depth. And the creatures that evolved in it would be shaped by all of those differences, in ways we cannot fully anticipate, into forms that might be as different from Earth's marine life as Earth's marine life is from anything we find on land. But the ocean, as an environment, has a logic to it that probably does not change from world to world. Sunlight penetrates to a certain depth and supports photosynthesis or its equivalent. Below that, in the deep water, creatures find other ways, chemical energy, the slow rain of organic matter from above. Food chains build from the bottom up. Things eat other things. Things evolve to find each other and to evade each other and to find partners and to raise young and to die and become food for something else. The ocean does not need to be Earth's ocean to be an ocean. Some habitable planets could develop enormous inland seas larger than Earth's continents, creating climates shaped almost entirely by water and storms. Earth's largest lake, the Caspian Sea, is a modest thing by planetary standards. But on a larger world, or a world where the distribution of land and water went differently, inland seas of extraordinary scale could develop. Seas so large that the climate of the surrounding land would be entirely dominated by them. Every storm is shaped by the vast evaporation from their surfaces. Every season is defined by the temperature cycles of their enormous thermal mass. Civilizations that grew up on the shores of such seas would have a fundamentally different relationship with water than any Earth civilization. The sea would not be the edge of the world. It would be the center, the defining fact of geography and weather and trade and travel. An inland sea large enough to create its own weather systems would generate storms over its surface that would rival anything in Earth's atmospheric history. The meeting of warm, moisture-laden air rising from the water with colder air coming off the surrounding land, repeated again and again across seasons, building into systems of extraordinary power. And the coastlines of such seas would be among the most dynamic environments in the solar system, especially on worlds where the gravitational influence of multiple large moons created complex tidal patterns. Habitable planets with multiple large moons would experience complex tidal patterns, creating unusual coastlines and constantly shifting ocean currents. Earth's tides are governed primarily by our single moon, with a secondary contribution from the sun. The result is a tidal pattern that, while not entirely simple, has a regularity that any sailor or shore dweller eventually learns to read. But a world with 2 or 3 large moons would have tidal forces that add and subtract and interfere with each other in complex ways. Some days, all 3 moons might align and pull the ocean in the same direction, creating tides of extraordinary height. Other days, they might oppose each other, and the tides would be almost flat. The coastlines of such worlds would be shaped by those complex forces. The intertidal zone, the area between the highest and lowest water levels, would be vast and varied, home to ecosystems that have evolved to survive constant and unpredictable change. Life in the intertidal zone on Earth is already among the most resilient and adaptable on the planet. Life in a complex multi-moon tidal zone would be extraordinary. Things that can cling to rock against powerful surges. Things that burrow deep when the water retreats and emerge quickly when it returns. Things that have learned to read the gravitational music of multiple moons and time their lives to its irregular rhythms. And the weather of such a world, already shaped by enormous seas and complex tides, would add its own drama. Weather on the newly habitable planets would still be wildly different from Earth's, with some worlds experiencing storms larger than entire continents. We have touched on this before, the dust storms of Mars, the permanent atmospheric storms of Jupiter, but it is worth returning to in the context of ecosystems, because weather is not just a backdrop to life. It is one of life's most powerful shaping forces. The organisms that survive on a world with continent-scale storms are not the same organisms that would survive on a gentle, stable world. They are hardier, more patient, more deeply rooted, or more mobile depending on their strategy. The drama of the sky writes itself into the biology of everything that lives beneath it. A plant that survives a storm that covers an entire continent develops differently than a plant that has never experienced more than a gentle rain. A creature that regularly shelters from winds that could pick up an Earth-scale thunderstorm and carry it somewhere else develops behavioral patterns, physical adaptations, social structures that would be meaningless on a calmer world. The ecosystem of a stormy world is, in a fundamental sense, a storm ecosystem, shaped from the ground up by the violence and drama of the atmosphere above. And then, quietly beneath all of this, beneath the forests and the farms and the inland seas and the storms and the complex tidal zones, there is a possibility that is perhaps the most extraordinary of all. If intelligent alien microbes already existed somewhere in the solar system, humanity might finally discover life living beneath oceans, clouds, or underground ecosystems. In the real solar system, this is not as far-fetched as it sounds. Astrobiologists genuinely believe that the most likely places to find life in our solar system, if it exists anywhere other than Earth, are places like the subsurface ocean of Europa, the hydrothermal vents that may exist on Enceladus's seafloor, or perhaps the cloud layers of Venus, where temperatures and pressures exist that are not entirely hostile to life as we know it. Life, in other words, may already be hiding in the solar system, in the dark, beneath the ice, in the clouds, in places we have not yet reached with our instruments. In a solar system suddenly made habitable, suddenly opened up to human exploration and settlement, those places would finally be reachable. Not just reachable from above, from the perspective of spacecraft descending through an atmosphere, but reachable from within. From settlements on the surface, from laboratories built near the coastlines of those subsurface oceans, from the slow and patient work of drilling and descending and finally arriving at whatever has been living there, in the dark, for perhaps billions of years. What would that meeting be like? A single-celled organism, or something no more complex than a simple multicellular creature, found in the deep water of a moon's hidden ocean, small, profoundly small by any ordinary measure. And yet it would be the most significant discovery in the history of human civilization. It would mean that life was not an accident of Earth. Not a singular, unlikely event that happened once and only once in the 4.5 billion years of the solar system's history. It would mean that life happens. That given the right conditions, given liquid water and chemical energy and time, something alive reliably appears. And if life appears reliably in our solar system, in the dark, cold, hidden places we have not yet looked, what does that say about the rest of the universe? About all those other stars, all those other planetary systems, all that space we have been looking at for our entire history and wondering about? It would say something extraordinary. Something that changes the fundamental background note of human existence, the way we described at the very beginning of this journey. The loneliness, the sense of singular improbability, would not just be diminished. It would be gone, replaced by something far larger and far warmer. The understanding that life is what the universe does, when the conditions allow. That we are not an exception. We are an example. And in a solar system full of habitable worlds, full of their own forests and their own storms and their own creatures drifting through turquoise atmospheres and deep blue seas, that understanding would not be abstract. It would be visible from where you stood every time you looked at the sky. There is a question that does not get asked often enough when we imagine human beings living on other worlds. We spend a great deal of time thinking about the engineering, the spacecraft, the habitats, the life support systems, the logistics of getting from one place to another across the enormous distances involved. We think about the geology and the weather and the resources available. We think about the extraordinary visual experience of standing on an alien world and looking up at an alien sky. But we do not always stop to ask the quieter, more intimate question. Not what those worlds look like to us, but what they would do to us. What would happen, slowly and inexorably, over years and generations and centuries, to human beings who were not just visiting those worlds, but living on them. Being shaped by them the way every living thing is shaped by the environment it inhabits. Because the human body is not a fixed thing. It is not finished. It is the product of a particular evolutionary history, yes, shaped by millions of years on a particular planet with particular gravity and particular sunlight and particular temperatures and particular day lengths. But it is also responsive. Plastic in the biological sense, capable of change, capable of adaptation, capable of drifting over enough time and enough generations into something slightly different from what it was. In a solar system full of habitable worlds, with human populations settling on planets and moons with wildly different physical conditions, that drift would be one of the most fascinating and profound processes in human history. The slow, quiet divergence of one species into many varieties, each one carrying in its body the signature of the world that made it. Let us begin where we have already spent some time. With gravity. Gravity differences would change the way life evolves, allowing taller forests, longer leaps, and lighter movements on smaller planets like Mars compared to Earth. We talked about the forests in the last act, those enormous low-gravity trees stretching to heights impossible on Earth. But the same logic applies to the people who would live beneath those trees, and to the way they would move through the world. Movement on Mars, with its 38% of Earth's gravity, would feel fundamentally different from movement on Earth. Your body, which here has learned to carry its own weight with a certain familiar effort, would suddenly be carrying much less. A person who weighs 70 kilograms on Earth would effectively weigh about 26 kilograms on Mars. Not lighter in the sense of having less mass, your muscles and bones would still be what they are, but lighter in the sense of what the planet is pulling you toward the ground with. The effort of standing, of walking, of climbing, of lifting things would all be reduced. The first weeks on Mars would feel, for an Earth-born person, almost like a dream. Like moving through water that offers no resistance. A step that on Earth would carry you half a meter forward might carry you a full meter on Mars if you were not careful about calibrating your effort. Jumping, something most adults rarely bother with on Earth because the energy required for the brief, low result does not seem worth it, would become genuinely pleasurable. You could leap in a way that felt like flight. Not quite flight, not the extraordinary ballistic arcs that the astronauts managed on the moon, but something between walking and flying that the Earth-born body has never experienced and that the Martian-born body would grow up taking entirely for granted. And those Martian-born people, what would they be like? Children born on low-gravity worlds might grow taller and develop weaker bones compared to humans raised on Earth's stronger gravity. This is not speculative in the way that some of our imaginings are. It is based on what we know about how the human body responds to gravity. Our bones are not static structures. They are living tissue, constantly being broken down and rebuilt, and the rate at which they rebuild is partly regulated by the mechanical stress placed on them. Gravity is one of the primary sources of that stress. When you walk and run and carry your own weight against Earth's pull, your bones receive constant signals that they need to be strong. They respond accordingly. In lower gravity, those signals are weaker. The bones of a child growing up on Mars would not receive the same constant mechanical encouragement to grow dense and strong. They would be lighter, more fragile perhaps than Earth bones. But also, and this is the beautiful side of the same equation, they might allow their owners to grow taller. Because the skeleton does not need to be as massively constructed to support a body that the planet is only pulling gently toward the ground, the constraints on height that Earth's gravity imposes would be relaxed. Martian children might be slender and tall in a way that Earth populations are not, with a particular quality of movement, graceful and light and effortless, that Earth-born visitors would find striking. They would also, in all likelihood, find Earth almost unbearable if they visited it. To a body that grew up under Martian gravity, Earth's pull would feel crushing. Every step would be an effort. Lifting your own arms would require noticeable muscle engagement. The simple act of standing up from a chair would feel like work. An Earth visit for a Martian-born person would be something like the experience of a deep-sea diver ascending slowly, every movement weighted with a pressure that the body never learned to consider normal. Over long periods of time, separate planetary populations could evolve slightly different physical traits because of gravity, atmosphere, and environmental conditions. Not just height and bone density, but everything. Skin pigmentation would change in response to different levels and types of radiation. Lung capacity and oxygen efficiency would shift in response to different atmospheric compositions and pressures. The senses would recalibrate, eyes adapting over generations to different qualities and intensities of light, ears adjusting to different atmospheric densities that change the way sound travels. These changes would be slow, generational, the kind of change that no individual would witness in themselves, but that a historian looking across 3 or 4 centuries of a planetary population's records might begin to notice. Gradually, the people of each world would become, in subtle but measurable ways, of their world. Not alien to each other, not so different that they would not recognize each other as the same species, as family, as fellow human beings, but distinct. The way populations on different continents of Earth developed distinct physical characteristics over tens of thousands of years of relative isolation, shaped by their different climates and altitudes and latitudes. The people of Mars would look Martian. The people of Venus would look Venusian. And a traveler walking through a crowded port, some imagined a future transit hub where all these different populations passed through, might see all of human history written in the variety of the people around them, each group carrying in their body the quiet record of the world that made them. Now let us move to the outer worlds and to a different kind of adaptation. Not to gravity, but to light, or rather to the lack of it. Humans born on outer planets might develop a stronger tolerance to darkness and colder temperatures compared to people raised on Earth. We are already a species with remarkable range in this respect. People who grow up in Arctic latitudes develop physiological and behavioral adaptations to long winters, to cold, to months of reduced sunlight that differ from people raised in tropical climates. The differences are not dramatic, but they are real and measurable. The outer solar system would push that variation much further. Living under weaker sunlight for generations could affect human sleep cycles, emotions, and even the way people design their homes and cities. The human body's circadian rhythm, that internal clock that tells us when to sleep and when to wake, is calibrated by light, specifically by the particular quality of blue spectrum daylight that signals to our brains that it is daytime and we should be alert. In the outer solar system, that signal would be weaker. The sunlight reaching Neptune or Uranus is a pale echo of what washes over Earth every morning. And the bodies of people living there over generations would learn to work with what they had. Sleep cycles might lengthen or become less rigidly tied to the presence of sunlight. The relationship between light and wakefulness, which for Earth humans is so fundamental as to feel hardwired, might soften the outer worlds into something more flexible. A Neptunian population might think nothing of sleeping at hours that would seem unusual to an Earth person, or of maintaining productivity through long stretches of dim, star-soaked sky that an Earth person would experience as the middle of the night. And emotionally, this is perhaps the most intimate effect of all. Light is not just a practical necessity for human beings. It is deeply tied to mood, to well-being, to the quiet emotional regulation that keeps a person feeling balanced and alive. The bleakness of seasonal affective disorder, the depression that affects some people in high-latitude winters when sunlight is scarce, is a small and temporary version of what generations of life in the outer solar system's perpetual dimness might do to human populations without some form of adaptation. Adaptation would come. It always does. But it would shape the people who experienced it in ways that went down to the bone. The cities of the outer worlds might be designed around light in a way that Earth cities simply are not. Every surface that could reflect light would reflect it. Interior spaces would be flooded with warm, carefully calibrated artificial light that worked against the dimness outside. Public gathering places might be designed with something almost liturgical. Spaces where warmth and brightness were concentrated and shared, where the community came together not just for social reasons but for the simple, biological need to be in the light together. And the homes of the outer worlds might be, in their own way, some of the most beautifully and thoughtfully designed spaces in the solar system. Because when the outside world is cold and dim and the sky is always partly dark, what you build inside becomes everything. The textures, the colors, the warmth, the particular quality of the light. All of it crafted with a care that you might not bother with if you could simply step outside into a bright and generous afternoon whenever you needed reminding that the world was good. Now let us think about travel between these worlds and what it would feel like to move from one to another. Because in a solar system of habitable planets, travel would eventually become possible. Not easy, the distances are still enormous, but possible. And the experience of moving between worlds with such different physical conditions would be one of the most disorienting things a human being could do. Travelers visiting different planets would constantly experience different body weights, making simple activities like walking, lifting objects, or even sleeping feel profoundly unfamiliar. Imagine arriving on Jupiter, or rather, on some habitable layer of Jupiter's atmosphere, from Earth. Suddenly, you are in a gravity roughly 2.5 times stronger than what you grew up with. Every step lands with more force than you expected. Your legs, accustomed to lifting your body against 1 Earth's worth of pull, must now work against 2.5 Earth's worth. You feel heavy, not metaphorically heavy, not tired heavy, but physically heavy in a way that is impossible to ignore. Your arms feel like they belong to someone larger. Picking up a cup of water requires a different amount of effort than your muscle memory has programmed for. Sleeping would be strange too. On Earth, lying down and feeling the bed support your body is a sensation so familiar it is essentially invisible. In a high-gravity world, the pressure of the mattress against your body would be different. More insistent. Your spine would settle differently. The experience of rest, of being horizontal and released from the effort of standing, would have a different quality, more intense perhaps, in a way that might be welcome after a day of moving through twice your usual gravity. And then, leaving for Mars, the opposite effect. That sudden lightness, that feeling of almost floating, of having to remind yourself to press your feet firmly against the ground or you will overshoot your intended destination. The first meal on Mars after arriving from Earth or a high-gravity world. The act of bringing food to your mouth, a gesture so automatic you never think about it, now requires conscious recalibration. Your arm moves too fast. Your hand arrives before you expected. These adjustments would ease over days and weeks as the body recalibrates. But they would never be entirely absent for people who moved frequently between worlds. The experience of multiple planetary gravities would become part of what interplanetary travelers knew about themselves, the way long-distance sailors on Earth knew their sea legs, and long-haul pilots know the particular fatigue of crossing time zones. And time zones bring us to perhaps the most quietly confusing aspect of life in a multi-planet solar system. Day lengths would shape entirely different lifestyles across the planets. The variation is extraordinary. A day on Venus, a single rotation of Venus on its axis, lasts approximately 243 Earth days, longer than a Venusian year. A Venusian sunrise, for anyone waiting for it, would require a patience that no Earth-born circadian rhythm is remotely equipped for. Mars is almost familiar. A Martian day is 24 hours and 37 minutes, close enough to Earth's that early Mars settlers would find it manageable, if slightly disorienting. Jupiter's day is just under 10 Earth hours. If you grew up on Jupiter, your body's expectation of sleep and wakefulness would be calibrated to 10-hour cycles, and visiting Earth, where the day is nearly 2.5 times as long, would feel like a continuous, gentle jet lag that never quite resolved. Travelers moving between planets would experience constant jet lag because every world rotates at a different speed and follows a different daily rhythm. Jet lag is such an ordinary, manageable inconvenience on Earth, a few days of disrupted sleep when you cross enough time zones, that it is easy to underestimate how profound the equivalent experience would be when moving between planets. Not hours of adjustment, but days. Weeks, perhaps. The body's deep biological rhythms, the hormonal cycles and temperature fluctuations and sleep-wake patterns that are calibrated to a particular day length, would have to entirely rebuild themselves around a new rhythm. And then, when you move on to the next world, rebuild again. Interplanetary travelers would become experts in the management of their own biology. They would know which supplements supported circadian adjustment, which light schedules helped the body recalibrate, which activities were tolerable in the first foggy days of planetary adjustment and which should be saved for when the body had found its footing. They would develop a philosophical relationship with disorientation, the way experienced sailors develop a philosophical relationship with seasickness. Not resigned to it exactly, but accepting that it is part of the life they have chosen. And the calendar, the beautiful, bewildering chaos of the interplanetary calendar. Different planets would celebrate New Year's Day at completely different times, because each world takes a different amount of time to orbit the Sun. Earth's year is 365 days. Mars's year is 687 Earth days. Jupiter's year is 12 Earth years. Saturn's year is 29 Earth years. A single Neptunian year is 165 Earth years, longer than most human lifespans. What does New Year mean on Neptune? How do you celebrate the completion of an orbit that your grandparents began and your grandchildren will finish? Perhaps the Neptunians celebrate not the year, but some other cycle. The orbit of one of their moons. The return of some seasonal atmospheric phenomenon. Something on a timescale that fits within the span of a human life and can be marked and celebrated and passed on to the next generation with continuity. Different planets might adopt different time systems, making interplanetary calendars extremely confusing for travelers and businesses. On Earth, we already have this problem in miniature. Time zones, daylight saving changes, the difference between the Gregorian calendar and lunar calendars and other traditional calendars used around the world, These create a low-level complexity in international scheduling that anyone who has ever tried to arrange a meeting across several continents is familiar with. Now multiply that complexity by 8 planets and dozens of moons, each with their own day length, their own year length, their own local conventions for measuring and naming time. Some worlds count hours that are not Earth hours. Some keep a version of Earth's calendar as an interplanetary standard while also maintaining a local calendar for everyday use. Some do neither, having developed entirely original approaches to timekeeping suited to their world's particular rhythms. The navigation of all of this, the scheduling, the coordination, the simple act of agreeing on when something will happen, would require systems of conversion and translation that do not yet exist. Interplanetary time would become its own field of expertise. There would be people whose entire professional life was dedicated to managing the interface between different planetary time systems, keeping the commerce and communication and travel of a multi-world civilization synchronized across a dozen different definitions of what a day is. And for the ordinary person, the traveler, the person who simply wanted to call home from another planet and know when their family would be awake to receive the message, it would be a constant, small, daily negotiation. A reminder, as intimate as a phone call, of just how different each of these worlds truly was. How each one, in its own quiet way, moved to its own rhythm, breathed at its own pace, count time in its own language. And perhaps that is fitting. That time, the most personal and fundamental dimension of human experience, should be the thing that most clearly marks the difference between worlds. Not just the sky or the gravity or the color of the leaves or the temperature of the air, but time itself, the rhythm of days and years, the pace at which each world carries its people through their lives. In a solar system full of habitable worlds, there would be no single correct answer to the question of what time it was. Every world would have its own answer. Every world would be right, and the extraordinary variety of those answers, the 10-hour Jovian day and the 243-day Venusian day and the almost familiar Martian day and the endless Neptunian year, would be one of the clearest expressions of something worth remembering, that each world is itself, completely, unapologetically, beautifully itself, and that the universe, in making room for all of them, made room for an extraordinary variety of ways to be alive. There is something quietly remarkable about a city at night, seen from above, from a high window or a hilltop, or the descent path of an aircraft coming in to land after dark. A city reveals itself as something that daylight keeps hidden. In daylight, a city is functional. It is roads and rooftops and the particular geometry of buildings arranged according to whatever logic the planners and the centuries and the accidents of geography imposed on them. It is busy and purposeful and, in its own way, beautiful. But it does not glow. At night, it does. Every window has a small warmth. Every streetlight is a node in an enormous living network. The whole thing seen from above has a kind of organic quality, as if the city were a creature that had settled into the landscape and put down roots of light. You can read the history of it from up there, the dense, bright center where everything began, and the spreading, dimming edges where the city is still becoming, still reaching outward into the surrounding dark. Now imagine that image multiplied. Not one glowing city on one dark world, but cities across an entire solar system. Each one different, shaped by the particular demands and opportunities of the world it was built on. Each one glowing in its own way, against its own particular darkness. Together forming a kind of light scattered across the planets, a civilization that has finally, after all its long history on one small world, learned to build on others. What would those cities look like? How would the worlds they were built on shape them? What problems would their architects have had to solve that no architect on Earth has ever faced? And what would it feel like to live inside them, to grow up in a city that was not built on solid ground, or beneath a sky that was not quite sky, or in a gravity that made every building possible in a way that Earth's architects could only dream of? Let us begin with perhaps the most fundamental architectural challenge in this imagined solar system: the gas giants, and the specific, extraordinary problem of building somewhere that has no ground. Humans living on Jupiter or Saturn's floating habitats might never stand on solid ground, spending their entire lives drifting through endless oceans of clouds. Think about what that means for a moment. Not as a technical challenge, not as an engineering problem to be solved, but as a human experience. An entire life without the feeling of rock or soil or pavement beneath your feet. An entire life in which the floor beneath you is, if you descend far enough, just more atmosphere, thicker and hotter and stranger, but never resolving into the solid, reliable substrate that every human civilization in history has built on. The floating habitats of Jupiter or Saturn would need to be engineered with a kind of ingenuity that makes the most ambitious structures on Earth look straightforward. They would need to maintain their altitude, riding specific layers of the atmosphere where temperature and pressure sit within livable ranges. They would need to be large enough to be stable, to resist the turbulence of Jovian or Saturnian weather, those extraordinary wind systems that we have described before, without being flung apart or driven into layers of the atmosphere where conditions become lethal. They would need to generate their own power, recycle their own air and water, grow at least some of their own food. They would need, in other words, to be entire worlds unto themselves. Self-contained ecosystems floating in the atmosphere of an already extraordinary world. And they might be beautiful, because the designers of such habitats, faced with the psychological challenge of helping their inhabitants feel at home in an environment so fundamentally unlike anything humans evolved to inhabit, would likely make beauty a priority. Windows large enough to give every living space a view of the surrounding cloudscape. Open areas at the center of the habitat, parks, gardens, gathering spaces, designed to give the sense of an outside, of sky above and ground below, even when both of those things are, in the strictest sense, atmospheric layers of a gas giant. The architecture of floating habitats might be the most psychologically thoughtful architecture ever built. Because getting the psychology right would not be a luxury. It would be a matter of mental health, of keeping people sane and connected in an environment that, without careful design, might become profoundly disorienting. Some people, born in those habitats, would grow up never knowing anything else. The gentle, constant motion of a structure floating in an atmosphere. The cloud views from every window. The knowledge that below and above, in every direction, the planet goes on. For them, the concept of standing on solid ground would be an abstraction. Something they had read about, perhaps. Something they could intellectually understand but had never felt in their bodies. The solidity and stillness of Earth's ground, the thing that the rest of us take so completely for granted that we have no name for the feeling, would be, to them, an experience of the imagination rather than of the senses. Moving outward now, to the worlds that have solid ground but face a different challenge. The challenge of cold and dark. Cities on the outer planets might be built underground or beneath protective domes to stay warm against the extremely cold environments far from the sun. This is a solution that human beings have already, in a limited way, experimented with. Underground cities in extreme climates, the tunneled, connected systems of buildings in cold northern cities, the cave dwellings of ancient peoples in hot deserts, the buried habitats that space agencies have long discussed for potential Mars colonization. The principle is simple. The ground is a good insulator. Go deep enough, and the temperature stabilizes regardless of what is happening on the surface above. In the outer worlds, this would be not just a convenience but a necessity. The surface of a habitable but cold outer world, far from the sun's warmth, might be survivable on its own terms, not lethal, in the way that the real Neptune's surface is lethal, but genuinely cold. Cold enough that heating the entire surface to comfortable temperatures for human habitation would be an energy challenge on a planetary scale. Far more practical to concentrate warmth, to build inward and downward, or to enclose spaces with domes, and to heat what is inside. An underground city on the moon of Uranus, for instance, might be carved into the bedrock itself. Tunnels and chambers and connecting passages, illuminated entirely by artificial light, insulated from the cold above by meters of rock. The city would have no outdoor spaces in the traditional sense. No parks open to the sky, no streets that were not, in some sense, corridors. But it might have extraordinary interior spaces, grand vaulted chambers carved from the living rock, some large enough to contain small forests, others designed as open plazas where the ceiling was high enough that you could almost forget it was there. The scale of underground architecture, freed from the need to be weather-resistant and structurally competitive with an open sky, could be genuinely monumental. And then those cities would glow. That is perhaps the defining visual feature of the outer world cities, the way they would push back against the dark with light. Outer planets with weaker sunlight could inspire cities filled with glowing architecture, artificial daylight systems, and illuminated gardens that never truly become dark. We touched on this in the last act, in the context of human psychology and the need for light on dim worlds. But it is worth dwelling on the architectural expression of that need. Because when a civilization decides that light is precious, when light becomes something that must be created and managed and distributed rather than simply received from above, it changes what buildings look like, what public spaces feel like, what the city as a whole communicates to the people who live in it. Imagine walking through the center of a large city on Uranus. The sky above, if you can see it through the dome or the panels overhead, is that particular turquoise and dim that we have described. Beautiful, but not bright, not warm. The city beneath it is different. Every building surface that faces a common space is luminous. Not painfully bright, not the harsh brightness of a spotlight, but softly, warmly lit in a way that has been carefully calibrated to approximate the feeling of an afternoon on Earth. The gardens between the buildings are filled with plants grown under full-spectrum lights, their leaves an extraordinarily vivid green against the general dimness of the world outside the dome. Fountains catch the light and scatter it. The pathways glow gently underfoot. And because it never truly becomes dark in these cities, because darkness in a world with insufficient sunlight is something to be kept at bay rather than welcomed, there would be a different quality to the rhythm of day and night. Not the sharp transition from bright to dark that Earth cities experience, but a gentler dimming. The city settles into a softer illumination at night, the gardens dimming but not going dark, the buildings' glowing surfaces fading to something quieter. An artificial dusk carefully managed. The city finds its sleeping mode and offers it to its inhabitants. The architecture itself across the solar system would look nothing alike. Because of different gravitational forces, construction styles would vary greatly, with taller and thinner buildings possible on smaller planets. We have mentioned the tall forests of low-gravity worlds. The same logic applies to buildings. On Earth, the engineering challenge of a skyscraper is essentially a gravity problem. You are building a structure that must support its own enormous weight against Earth's continuous pull downward, while also resisting the lateral forces of wind. The taller you go, the heavier the structure, the more engineering you must dedicate simply to keeping it from falling down. At a certain height, the amount of the building's total volume that must be devoted to structural support becomes so large that the building ceases to be economically practical. On Mars, those constraints relax substantially. The same materials that could build a 50-story Earth skyscraper might support a building 2 or 3 times as tall on Mars. The skylines of Martian cities might be extraordinary things. Slender towers stretching to heights that Earth engineers would look at with professional envy and practical disbelief. Their proportions elegant in the way that things can be elegant when the forces working against them are less severe. And the mountains that would exist on those low-gravity worlds would provide a geological backdrop to match the architectural ambition of the cities built beneath them. On low-gravity planets, mountains could grow much taller before collapsing under their own weight, creating gigantic peaks unlike anything on Earth. This is a real astronomical phenomenon. Olympus Mons on Mars, which we have mentioned before, is the largest volcano in the solar system, 22 kilometers high, nearly 3 times the height of Everest. It exists at that scale precisely because Mars's lower gravity allows rock to pile up without the structure collapsing under its own weight. Earth's tectonic forces and Earth's gravity keep our mountains within a certain range of size. Other worlds play by different rules. A habitable Mars, with cities built in its valleys and on its plains, would have those extraordinary mountains on its horizon. The kind of horizon feature that dominates the entire visual experience of a landscape. Olympus Mons is so large that if you stood at its base, you would not be able to see the summit. The mountain is beyond the visual horizon from its own foot, too large to see whole from any point on the surface. It would simply be there, behind the sky, a presence more felt than seen from below, and glimpsed in its true scale only from high altitude. Imagine growing up in the shadow of a mountain like that. The way it would organize your sense of direction, your mythology, your dreams. Every culture that has ever grown up near a significant mountain has made that mountain central to its inner life. Sacred, dangerous, inspiring, defining. Olympus Mons would be those things to any civilization that lived near it, and at a scale that no mountain on Earth could quite match. The physical environment of these cities would also shape their sounds, in ways that their inhabitants might not even consciously register but that a visitor from Earth would notice immediately. On planets with thicker atmospheres, sound could travel farther and differently, allowing strange echoes and deeper natural noises across the landscape. Sound is pressure waves moving through a medium, and the denser the medium, the more efficiently it carries those waves. In a thicker atmosphere, like a habitable Venus with its particularly rich air, sounds would travel further. Voices would carry across distances that would require shouting on Earth. The acoustic quality of open spaces would be richer. The bass frequencies, the low, resonant sounds of wind and thunder and the natural deep noises of the world, would be more pronounced, felt in the chest as much as heard by the ears. A thunderstorm on Venus would not just be heard. It would be felt. A deep, subsonic presence, a vibration in the air and the ground that no Earth thunderstorm quite achieves. The echo of a voice in a canyon on Venus would last longer, return more fully. Music played in the open air on Venus would have a different quality. Fuller, richer, the harmonics sustained in ways that Earth's atmosphere does not support. Musicians and architects alike would discover, in their respective worlds, that their medium was different, that the rules they had learned, calibrated to Earth's particular atmospheric density, needed to be rewritten for the air they were actually working in. Concert halls on Venus might be designed to manage that extra richness rather than encourage it, to dampen the extraordinary carry of Venusian air into something that served the music rather than overwhelming it. And beneath all of these cities, sustaining them against the cold and the dark and the distances from the sun, would be the question of energy. Habitable worlds near the outer solar system might rely heavily on nuclear or fusion energy, because sunlight there would be far too weak for massive solar farms. At the distance of Neptune from the sun, the sunlight available is roughly 900 times weaker than what reaches Earth. Solar panels that could power a city on Earth would generate barely a trickle at that distance. The outer worlds would need a different answer, and the most likely answer in an advanced enough civilization would be fusion, the process that powers the sun itself, the joining of light atomic nuclei to release enormous energy, clean and extraordinarily dense. A city on Uranus or Neptune powered by fusion reactors would have, in a sense, its own small star buried in its foundations. Not the vast stellar inferno, obviously, but the same fundamental process, harnessed and controlled and converted into the power that keeps the lights on and the warmth circulating and the gardens growing and the people inside the dome comfortable while the cold, dim world continues outside. It is a remarkable image. Human beings, so far from the sun that its warmth can barely reach them, creating their own warmth. carrying their light source with them, the way a traveler in deep wilderness carries a lantern. The technology would be extraordinary, but the impulse would be ancient. The oldest human impulse there is: make fire, keep the dark at bay. And between all of these cities, between all of these worlds, the traffic. Massive space elevators might connect some habitable planets and moons to orbiting stations, making travel to space cheaper and more common. A space elevator is a concept that has been seriously discussed by engineers and physicists for decades. A cable extending from the surface of a planet to a station in orbit, along which vehicles could climb without the enormous fuel cost of a rocket launch. On Earth, the engineering challenge is extreme, requiring materials that barely exist. But on worlds with lower gravity, Mars, certain moons, the challenge becomes more manageable. A Martian space elevator, anchored somewhere in the equatorial highlands and extending up to a station in orbit, would make reaching space from Mars almost routine. Not the thunderous, expensive, dangerous event that a rocket launch represents, but something closer to a long elevator ride. Slow, predictable, available to anyone who needed to travel. At the top of those elevators, the orbital stations, and beyond them, the ships. Spaceports across the solar system could become as common as airports on Earth, with ships departing daily between planets and moons. Not instantly, the distances are still vast, even in a settled solar system, and travel times would range from weeks to years depending on the destination. But regular, scheduled, part of the ordinary fabric of interplanetary life. A Martian might book passage to Europa the way a person today books a long-haul flight. With some planning, with some patience, with the knowledge of roughly when they would arrive and what the experience would involve. Spaceports would be extraordinary places, not just for the technology they housed, but for what they meant. Every departure would be a departure from one world toward another. Every arrival would be the end of a journey between two genuinely different planets. The diversity of people moving through those ports, with their different heights and builds and the subtle physical signatures of the worlds that made them, would be a constant, living reminder of just how far the human story had expanded. And late at night, in the quieter hours of whatever the local time was, when the traffic thinned and the departure slowed, a window in an interplanetary spaceport would offer one of the most extraordinary views available to any human being. The sky above whatever world you were on. The stars, always the stars. And somewhere out there, points of light that were no longer just planets. That was, each of them, home to someone. Cities glowing in atmospheres. Towers rising in low gravity. Domes keep warmth alive in the dark. The patient pulse of fusion reactors deep in the rock of moons that the sun barely reaches. A solar system that had learned to make itself at home. Not one home, never again just one, but a whole, glowing, inhabited, breathing, building, traveling family of them. Each one is different. Each one is completely and beautifully its own. Each one contributes its piece to the largest and most improbable thing that any civilization has ever attempted. The project of making the universe feel like somewhere you belong. There is a map in a museum in Lisbon, Portugal, that is worth thinking about for a moment. It was made in the early 16th century, not long after Portuguese explorers had completed the first circumnavigation of Africa and established sea routes to India and the Americas. The map shows the world, or rather, it shows the world as it was then understood by European cartographers who were working at the very edge of what was known, trying to record a geography that was expanding faster than the ink could dry. The coastlines of Europe and the Mediterranean are drawn with confidence and accuracy, the product of centuries of careful navigation. But the further the map extends from those familiar shores, into the Americas, into the interior of Africa, along the coasts of Asia, the more approximate it becomes. The shapes are wrong. The proportions are off. The coastlines dissolve into speculation and then into blank space, labeled with the honest admission that there is simply nothing yet to record. And then there is the ocean, between the known and the unknown, between the ports of Lisbon and Seville and the distant shores that the ships were still in the process of discovering. There is nothing but water. Vast, empty, traversed by lines that represent the routes the ships took. Arrows showing prevailing winds. Careful notations of currents. The ocean is not blank. It is annotated with all the practical knowledge that sailors had accumulated about how to cross it. But it is sparse. It is the space between things, not a thing in itself. Now imagine a map of the solar system drawn at a comparable moment. Not in the age of first exploration, that age has already passed, but in the age of first settlement. When the worlds are being opened and the routes between them are being established and the blank spaces are beginning to fill in. When people are beginning to travel, not as explorers on missions of discovery, but as settlers and workers and tourists and families. When the solar system is starting to look less like an astronomical diagram and more like a world that people actually live in. What would that map look like? Where would the trade routes run? Where would the traffic concentrate? Which worlds would be the hubs, the crossroads, the places where the routes converged and the population was densest and the lights, seen from space, burned brightest? And perhaps most interestingly, which world would sit at the center of all of it? Earth's moon could become one of the most important travel hubs in the solar system, acting like a giant cosmic airport connecting routes across the entire system. This makes a certain elegant sense when you think about it. The moon is close to Earth, close enough that a journey there takes days rather than weeks or months. It has lower gravity than Earth, which means that launching from it requires far less energy than launching from Earth's surface. A ship that has made the long journey from Jupiter or Saturn or Neptune, decelerating over weeks to arrive in the inner solar system, might find it far more practical to dock at a lunar hub than to descend all the way down into Earth's gravity well and then climb back out again. The moon as a hub, as a port, as the great exchange point of the solar system's commerce and travel. It is a role that geography, in the astronomical sense, seems almost to have designed it for. Close enough to Earth to be connected, distinct enough from Earth to be neutral. Large enough to support significant infrastructure, far enough outside Earth's gravity to make departure to the wider solar system efficient. A lunar spaceport, in this imagining, would be one of the most extraordinary places in the civilized solar system. Not for its beauty, the moon, made habitable, might have a stark and lovely landscape of plains and mountains and the clean light of a nearby Earth hanging overhead, but for its human texture. The density of transit, the variety of people and goods and ships passing through. Travelers from Mars, still adjusting to the slightly higher gravity of the inner solar system after their months-long journey. Freight ships from the asteroid belt, heavy with processed metals and rare minerals, waiting in lunar orbit for cargo shuttles to take their loads down to Earth. Passenger vessels preparing for the long outward journey to the gas giants, taking on supplies and passengers and the carefully calculated fuel loads that will sustain them across the distances involved. And speaking of the asteroid belt, the asteroid belt between Mars and Jupiter might transform into a chain of mining colonies, research stations, and artificial habitats supporting interplanetary civilization. The asteroid belt is not what science fiction sometimes depicts it as, not a dense, dangerous labyrinth of tumbling rocks that spacecraft must navigate with skill. In reality, the asteroids are spread across an enormous volume of space, and a ship could travel through the belt for a lifetime without ever coming close to one. But they are there. Hundreds of thousands of them. Some are tiny. Some, like Ceres, which is large enough to be classified as a dwarf planet, genuinely substantial. And they are made of things that a growing interplanetary civilization would need urgently. Metals, iron, nickel, cobalt, platinum group metals, which are rare on Earth but present in some asteroids in concentrations that would make any miner's eyes widen. water ice in the darker asteroids, which can be converted to fuel as easily as it can be drunk. The asteroid belt is, in a real sense, the hardware store of the solar system, the place where the raw materials are. A civilization that needed those materials, that was building cities on Mars and floating habitats at Jupiter and domed outposts on the moons of Saturn, would go to the belt and get them. And the people who went to get them would, over time, stop going home, would build homes there instead, in hollowed-out asteroids or on the surfaces of the larger ones or in purpose-built rotating habitats that provided their own gravity by spinning. Research stations would cluster near the most scientifically interesting bodies. Medical facilities would establish themselves to serve the mining population. Schools would open for the children born there who had never seen a planet's surface. The belt would become a civilization in its own right, scattered and sparse by the standards of a planetary surface, but real, with its own culture, its own way of doing things, its own particular outlook shaped by the experience of living in the space between worlds, where the sun is a strong star rather than a disk and the nearest planetary surface is weeks away in any direction. The belt, its people might call it, and themselves the Belters, a community defined not by a world they shared but by the spaces between worlds. And threading through all of this, between the belt and the planets and the moons and the lunar hub, the commerce. The reasons people move. Some planets might specialize in producing rare resources, creating massive interplanetary trade networks connecting the entire solar system. The logic of comparative advantage, the economic principle that says each producer should focus on what it does best and trade for the rest, would apply at an interplanetary scale just as it applies to nations on Earth. A world with vast deposits of some mineral rare elsewhere would export that mineral. A world with perfect conditions for growing some particular crop, the specific gravity and light and temperature that a particular plant thrives in, would grow that crop and send it outward. A world with extraordinary scientific infrastructure, perhaps because its particular environment makes certain kinds of research possible that cannot be done elsewhere, would export knowledge. The trade routes between them would grow like root systems, extending and branching and finding the paths of least resistance between supply and demand. And the ships that traveled those routes, not explorers' ships, not the fragile and heroic vessels of first discovery, but cargo haulers and passenger liners and fast couriers, the workhorses of a mature interplanetary economy, would be some of the most important objects in the solar system. Not glamorous, most of them, not the stuff of adventure stories, but essential, the connective tissue of a civilization spread across billions of kilometers. Over time, maps of the solar system would begin to resemble maps of Earth today, filled with trade routes, migration paths, and densely populated regions. Look at a map of global shipping routes or global air traffic, and you see the pattern of human commerce made visible. Dense lines between the great population centers, thinner lines extending to smaller hubs, the occasional lonely route to some remote but resource-rich place. The map is not random. It reflects history and economics and the particular human logic of how value moves and where people choose to live. A solar system trade map would have the same quality. Dense traffic in the inner solar system between Earth and Moon and Mars, where the populations are largest and the distances shortest. Thinner routes extending outward to the belt. Long, carefully calculated paths to the gas giants and their moons, traveled less frequently because the journey is longer and the fuel cost higher, but traveled nonetheless because the resources and the people at the other end make it worthwhile. And the map would change over time, as new settlements grew and old ones shifted, as new resources were discovered and new technologies made previously impractical routes possible. Looking at that map in some future era, at all those lines connecting all those worlds, a person might feel something of what a ship's captain in the Age of Sail must have felt looking at a globe and seeing, for the first time, that all the world's oceans were connected. That you could, in principle, sail from anywhere to anywhere. That the world was, despite its apparent vastness, a single continuous place. The solar system in this imagining would be the same, a single continuous place, vast but navigable, connected by lines of commerce and travel and communication that made the distances, while never trivial, at least manageable. Space tourism would become one of the greatest industries in human history, with travelers visiting methane blue sunsets on Neptune or giant ring shadows stretching across Saturn's skies. The impulse that drives tourism, the desire to see things that are different from the things you already know, to expand your sense of what the world is and what it contains, would not diminish in a solar system of habitable worlds. It would expand dramatically along with the available destinations. Some planets might become famous vacation destinations because of their beautiful skies, calm weather, or spectacular cosmic views visible every night. Think of what the tourism brochure for Saturn's largest moon might look like. The ring shadows that move across the golden sky. The gas giant itself, enormous and magnificent, visible through the haze. The particular quality of the light, filtered and soft and amber. The slow, giant rain falling through thick air. There are places on Earth, the Maldives, the Himalayas, the Norwegian fjords, that people travel to simply for the experience of being there, for the particular beauty of that specific place. Saturn's moon would be that, at a scale and intensity that no earthly destination could approach. Neptune, with its deep blue oceans and its faint twilight days and its extraordinary auroras, would attract a different kind of traveler. The kind who goes to remote places not for comfort but for the experience of genuine remoteness. The kind who wants to stand somewhere genuinely unlike everywhere else and feel the full weight of that difference. Neptune would be, in interplanetary tourism terms, the equivalent of Antarctica or the deep Amazon. Not an easy destination, not a comfortable one, but one that left its mark on everyone who made the effort to reach it. And the experience of traveling there, of spending months in space between departure and arrival, that too would become part of the attraction. Transportation across the solar system could eventually include massive rotating space hotels where travelers spend months during long journeys between planets. Rotating because rotation provides artificial gravity and months of weightlessness, while manageable for trained astronauts, is not a comfortable or healthy experience for civilian travelers. The rotation creates a centrifugal force that presses outward, simulating gravity on the inner surface of the rotating section. Walk along the inner edge of the ring, and down is outward, and the sky is the center of the spinning structure, and the stars will pass the windows in a slow, continuous circle. A rotating space hotel on a 6-month journey to Saturn would be a strange and specific kind of luxury. Not the luxury of a beach resort or a mountain lodge. The luxury of genuine isolation, of being genuinely between worlds, of having nothing to do for months except read and talk and look out the window at a universe that grows imperceptibly different each week as you travel deeper into it. The sun, slowly shrinking. The inner planets, fading to points. Saturn, gradually brightening from a star to a disk to something with visible structure. Rings eventually catching the light. The community that would form on such a ship, over such a journey, would be unlike almost any community on Earth. Thrown together by circumstance and schedule, confined to a modest space for months, sharing meals and common areas, and the experience of watching the same universe slowly change outside the same windows. Friendships made on those journeys, between people who might never have met in the ordinary geography of their respective worlds, would have a particular intensity. The kind of intensity that comes from shared experience in an unusual situation. Future travelers moving between planets regularly, those who commuted between worlds for work or family, would carry those friendships with them across the solar system. A person who grew up on Earth but worked on Mars and had family on the moon of Jupiter would have a social network distributed across hundreds of millions of kilometers. The concept of being far from home would take on entirely new meaning, because home for such a person might not be a place at all. It might be a set of relationships scattered across the solar system, connected by long communication delays and occasional, precious visits. And those communication delays, they bring us to one of the most interesting constraints on interplanetary civilization: the speed of light and what it means for a society spread across the solar system. Interplanetary internet systems would need giant relay stations across space, because normal communication networks would struggle over such vast distances. The internet, as we know it, works because the signals travel at the speed of light and the distances on Earth are small enough that this speed makes communication effectively instantaneous. Send an email from London to Tokyo and it arrives in milliseconds. The delay is so small as to be imperceptible. Between planets, the delays are not imperceptible. Communication between planets would not be instant. Radio signals could still take hours to cross the solar system, depending on planetary positions. At their closest, Earth and Mars are about 3 light minutes apart. At their furthest, when they are on opposite sides of the Sun, they are over 20 light minutes apart. Send a message to Mars and it arrives between 3 and 20 minutes after you sent it, depending on where in their orbits the two planets happen to be. Earth and Jupiter, between 33 and 53 light minutes. Earth and Neptune, between 4 and 5 light hours. A conversation between Earth and Neptune would be impossible in the way we think of conversations. You would speak or type or record your message and send it. And 4 to 5 hours later, a response might begin its journey back. Not a conversation, but a correspondence. A slow, deliberate, thoughtful exchange of messages that has more in common with letters sent by ship across an ocean than with anything we currently think of as communication. The relay stations that would make this communication possible, enormous arrays positioned at strategic points across the solar system, receiving signals and amplifying and retransmitting them, would be some of the most critical infrastructure in an interplanetary civilization. Not glamorous, not the kind of thing that features in tourist brochures, but essential in the way that roads and bridges and undersea cables are essential on Earth. The invisible skeleton of a connected civilization. And the culture that developed around those communication delays would be fascinating. People who lived on the outer worlds would develop a different relationship with communication than Earth people or even Martians had. More patient, necessarily. More accustomed to crafting a complete message rather than a response, because you could not wait to see what the other person said before deciding what to add. More accustomed to the idea that connection did not require immediacy. That a relationship could be sustained across a 4-hour communication gap with care and effort, the way relationships in previous centuries were sustained across months of mail delay. The letters people sent each other across those distances might be some of the most carefully written correspondence in human history. Not because people in the outer solar system would be more literary than people elsewhere, but because when you know your words will take 5 hours to arrive and 5 hours to get a response, you choose them with a different kind of care than you do when a reply is seconds away. You think about what you actually mean. You try to anticipate responses. You write, in other words, the way people used to write when writing was the only option and the option was expensive and slow. And perhaps there is something to be valued in that. In a civilization that stretched from Mercury to Neptune, where the fastest possible communication between the extremes took the better part of a day, the depth and care of that communication might be one of the defining cultural achievements of the age. An interplanetary civilization would know, in a way that our speed-saturated current world sometimes forgets, that meaningful connection is not the same as instant connection. That the value of what is said does not depend on how quickly it arrives. The map of the solar system in this age would be a map of connections. Physical connections, the trade routes and passenger lanes and cargo paths, and communicative connections, the invisible web of signals moving at the speed of light between relay stations and planets and ships. Both kinds of connection are patient in their way. Both kinds accept the distances and the delays as simply the terms of the life being lived. A civilization at home in the solar system would be a civilization that had made peace with scale. With the fact that some journeys take months and some messages take hours and some distances cannot be shortened by any technology available. It would be a civilization that had learned to be patient in a way that no entirely earthbound civilization ever quite needed to be. And in that patience, perhaps something interesting would grow. A different relationship with time. A different sense of what it means to be connected to other people. A different understanding of home, not as the place you currently are, but as the web of relationships and communities that you belong to, however scattered across the solar system they might be. A civilization that had expanded across 8 planets and dozens of moons and a belt of asteroid colonies and a network of relay stations and a constellation of rotating hotels moving slowly between worlds would still be, at its heart, the same civilization that began on one small blue world. Still made of people who needed warmth and connection and meaning and the occasional, extraordinary experience of looking up at a sky full of light and wondering what was out there. The difference would be that they would know. They would have been there. They would have looked back from all of those other worlds at the small bright point of Earth and understood in their bones what they had come from and chosen, freely and with full knowledge of the alternatives, to keep building, to keep traveling, to keep reaching outward and outward into the universe that had been there all along, waiting patiently for the day when the life it had made was ready to come home to it. There is a word in Portuguese, saudade, that does not translate cleanly into English. It describes a kind of longing, a melancholy tenderness for something loved that is absent or lost, or perhaps never quite possessed in the first place. It is the feeling of missing something that was beautiful, tinged with the knowledge that the missing itself is a form of love. Other languages have their own versions of this feeling, their own particular words for the specific emotional textures that their cultures have found important enough to name. The Japanese have mono no aware, the bittersweet awareness of impermanence. The Germans have Weltschmerz, a world weariness, a pain caused by the gap between how the world is and how it ought to be. These words exist because language does not just describe experience. It shapes it. The words a culture develops, the concepts it decides are worth naming, the distinctions it chooses to draw between feelings or ideas that another culture might group together or ignore entirely. All of these reveal something about what that culture has noticed, what it has found important, what aspects of being alive it has decided deserve their own corner of the vocabulary. And now imagine 8 planets and dozens of moons, each one home to a human population living under different skies, experiencing different seasons, counting different years, shaped by different gravities and different lights and different weathers. Each one, over decades and then centuries and then longer, developing its own particular angle on what it means to be alive. Its own things worth noticing, its own feelings worth naming. Different planets would likely develop unique cultures, accents, traditions, and calendars as communication delays and environmental differences slowly separate human societies. This is not a speculation. It is a pattern. It is what human beings have done everywhere and always, whenever a population has been separated from another population by distance and time and different circumstances. The same species, the same fundamental biology, the same deep evolutionary inheritance of curiosity and sociality and the need for meaning, and yet, given enough separation, enough difference in environment, enough generations living under different conditions, something new emerges. Something that would not have emerged anywhere else, because it could only have grown from these particular conditions, this particular sky, this particular relationship between the sun and the seasons and the land. Cultures are, in this sense, the accumulated response of a group of people to the specific world they live in. And in a solar system of genuinely different worlds, the cultural divergence would be spectacular. Language would be the most intimate expression of that divergence. If humans spread across every habitable planet, languages would slowly evolve in different directions, eventually creating entirely new planetary dialects. This has already happened on Earth, more times than we can count. Latin, spoken across the Roman Empire, fragmented over centuries into Italian and Spanish and Portuguese and French and Romanian, each one shaped by the particular populations that spoke it and the languages they mixed it with and the sounds their local environment rewarded. English, carried to the Americas and Australia and South Africa, developed distinct varieties in each place, different pronunciations, different vocabularies, different idioms that reflect the particular experiences of people living in those particular places. On different planets, the same process would unfold, but with more extreme inputs. The vocabulary a Martian population developed would reflect Martian realities. Words for the quality of dust storm light, for the particular cold of a Martian night, for the precise visual character of Earth seen as a blue star in the evening sky. An Earth person encountering Martian speech after a few centuries of divergence might find it recognizable in its bones but strange in its surface, the way an English speaker finds a Scottish dialect or a Jamaican patois, clearly related, clearly coming from the same root, but carrying the unmistakable signature of a different place. And the further the worlds diverged in environment, the further the languages would diverge in character. A Neptunian dialect, shaped by centuries of living in dim light with long communication delays and the particular philosophical orientation that such a life encourages, patient, deliberate, accustomed to waiting, might develop a different relationship with tense and urgency than languages developed on the busy inner worlds. A Jovian dialect, shaped by the floating, wind-carried, boundaryless nature of life in an atmospheric habitat, might develop spatial and directional vocabulary with none of the up-and-down certainty of a language developed on a solid surface. Eventually, given enough time, these might become languages rather than dialects, mutually unintelligible, requiring translation. The children of the outer worlds grow up speaking something that their Earth ancestors would not recognize, using sounds and structures shaped by the particular demands of their world. But language would be only the most obviously communicable of the cultural differences. The arts would run deeper. Music, art, and architecture would likely evolve differently on each planet, inspired by alien landscapes, unusual skies, and unfamiliar weather patterns. Art is always, at some level, a response to the world. The particular shapes and colors and sounds that a culture finds beautiful are not arbitrary. They are shaped by the landscape the culture grew up in, by the quality of the light it lived under, by the weather patterns it experienced, by the sounds of the natural world around it. The particular aesthetic of Japanese art, its appreciation of negative space, its attention to transience, its sensitivity to the beauty of imperfection, cannot be fully separated from the landscape and climate and seasonal rhythms of the Japanese islands. The particular architectural character of Mediterranean cultures, the whitewash and the courtyard and the thick walls designed for shade, is a direct conversation with the sun and the heat. In other worlds, those conversations would be with entirely different partners. A Venusian artistic tradition, developing over centuries in response to those long amber rains and those orange-tinted sunsets, and that particular quality of diffused tropical light, might develop a visual culture saturated with warmth and flow and softness, an aesthetic of immersion, of being surrounded and enveloped rather than positioned and framed. A Martian artistic tradition might go in the opposite direction. The stark, clean lines of a world where the horizon is always visible, where the air is clear, where the landscape is ancient and minimal and the sky is rarely overcast might produce an art of clarity and space. Vast, uncluttered compositions. An appreciation for the beauty of simplicity, of a single color seen at great depth, of the particular quality of light on dust. And the music. Future musicians on distant worlds might create instruments designed around local atmospheric conditions, producing sounds impossible on Earth. We touched on this briefly before, the richer, fuller sound of a denser atmosphere. But it goes beyond just the way existing instruments would behave. A civilization that grows up in a particular acoustic environment builds instruments designed for that environment, exploiting its particular properties to produce sounds that environment makes possible. A Venusian instrument designed to take advantage of that dense, rich atmosphere might produce bass frequencies of extraordinary depth and sustain, sounds that Earth instruments cannot approach because Earth's air is not dense enough to carry them. A Martian instrument, designed for a thinner atmosphere, might go the opposite direction, emphasizing the higher frequencies that thin air carries well, producing bright, clear, penetrating sounds with a quality unlike anything built for Earth's acoustic environment. An instrument played in the floating habitats of Jupiter, where the atmosphere itself is a different medium, might produce something entirely alien. Tones that have no equivalent in any Earth-born musical tradition. The idea of encountering, for the first time, a musical tradition from another world, sitting in some interplanetary concert hall and listening to musicians from Neptune play instruments designed for Neptunian air, producing sounds that no human ear born on Earth has ever heard before, is one of the most exciting cultural prospects of an inhabited solar system. Not better or worse than Earth music. Not more or less sophisticated. Simply different in the profound and irreducible way that different worlds are different. Now let us think about something more physical, more immediate, the games people play. Sports would change across the solar system, with athletes on low-gravity planets capable of jumping extraordinary heights or staying airborne much longer than any Earth athlete. Sport is, at its heart, a celebration of what the human body can do. And what the human body can do is radically different depending on the gravitational field it is operating in. The sports of Mars would be unrecognizable to an Earth sports fan, not because the competitive impulse or the desire for skill and strategy and physical excellence would be different, but because the physical vocabulary available to Martian athletes would be so much wider. A Martian basketball player, or whatever the Martian equivalent of basketball was, might routinely jump to heights that would make an Earth basketball player seem rooted to the floor. The entire geometry of the game would change. The strategies, the positions, the skills that were valued. A low-gravity gymnastics routine, with its extraordinary hang time and the sweeping balletic arcs available to a body that falls slowly, would be something entirely beyond anything in Earth gymnastics. Not more impressive, necessarily, in the absolute sense, just different. Using a different physical language. And the cultural investment in those sports would be as deep as any sporting tradition on Earth. The Martian equivalent of football stadiums, the Jovian equivalent of the Olympics, the interplanetary competitions that would eventually emerge between the various worlds. All of these would carry the same weight that sport carries on Earth. The weight of identity and pride and community and the simple, ancient pleasure of watching exceptional people do exceptional things with their bodies. Children on those worlds would grow up knowing the names of the great athletes the way children on Earth know the names of sports heroes, would argue about them, idolize them, try to imitate their movements in the low-gravity parks of Martian cities or the pressurized courts of asteroid habitats. The particular heroes would be different. The particular movements celebrated would be different. But the relationship between a culture and its athletes would be entirely recognizable. And those children would go to school. Schools on different worlds would teach different versions of local geography, focusing on nearby moons, rings, and regional space routes instead of continents. Think about what the geography curriculum looks like from a European classroom. The enormous presence of Jupiter, dominating the sky, the other moons of the Jovian system, Io with its extraordinary volcanic activity, Ganymede the largest moon in the solar system, Callisto pocked with ancient craters, the trade routes through the inner Jupiter system, the longer routes to Saturn, to the asteroid belt, to the inner planets. This would be the geography that a child born on Europa learned first. The local geography, the geography of their immediate world. Earth, in that curriculum, would be important but distant. Historically significant, the origin point of the species and the source of much of the culture and technology that spread outward. But not home, not the first reference point in a child's spatial understanding of the universe. A child on Europa would point toward Jupiter and say, "There is the center of my world," the way a child on Earth points at the ground and says, "Here is where I live." The history taught in those schools would also shift. Human history, as taught today, is inevitably organized around Earth, around the civilizations that rose and fell on particular continents, the migrations and the empires and the revolutions and the scientific discoveries. In an interplanetary solar system, that history would be the foundation, but an early chapter rather than the whole story. The later chapters, the first settlements, the great migrations outward, the development of the belt communities, the founding of the outer world cities, would be as important to a Neptunian student as the history of ancient Rome is to a European one. Foundational, but not personal. Personal history would be the history of their world. The first interplanetary universities could emerge, where students from dozens of worlds gathered to study science, history, and the cultures of the solar system. These places would be extraordinary, not just intellectually but humanly. A campus where students from Earth and Mars and the Jovian moons and the outer worlds lived and worked and argued and ate together, each one carrying the cultural assumptions of their home world, each one gradually having those assumptions made visible and questionable by contact with people for whom entirely different things were obvious. The friction of that contact, respectful, curious, sometimes bewildering friction, would be one of the most productive forces in interplanetary intellectual life. The discoveries that happen when a Martian physicist's intuitions, shaped by growing up in low gravity, encounter a Jovian atmospheric scientist's intuitions, shaped by growing up in floating habitats. The art that is made when a Venusian musician steeped in amber rain and dense atmosphere acoustics collaborates with a Neptunian composer whose entire aesthetic is built around dimness and distance. The philosophy that emerges when people from 8 different worlds, each with its own relationship to time and light and gravity and solitude, try to agree on what the important questions are. And those philosophical questions, they would not be small. Religious beliefs and philosophies could change dramatically once humans begin living permanently across multiple worlds under completely different skies. The great religious and philosophical traditions of Earth are, like everything else, shaped by Earth. The particular way Earth's sky looks, the particular rhythm of its days and seasons, the particular scale of its landscapes. The sense of human smallness that comes from looking up at the stars on a clear night. The sense of human significance that comes from the warmth of the sun and the abundance of the living world. Those inputs would be different in every world. A civilization that lived on a world where the sun was barely a bright star would have a different intuitive sense of humanity's place in the cosmos. The theological implications of discovering life in the subsurface oceans of Europa, if such life existed, would reshape every religious tradition in the solar system in ways that no single tradition could fully anticipate or absorb without change. The question of what it means to be human, always central to philosophy and religion, would become dramatically more complex when being human meant being one of 8 or 10 or 20 different varieties of humanity, each shaped by a different world. New philosophies would emerge, new spiritual traditions, rooted not in the specific landscapes of Earth, but in the specific experiences of other worlds. A Martian spiritual tradition shaped by the experience of long dust storms and the blue Earth in the evening sky and the immense geological silence of an ancient planet. A Neptunian mystical tradition built around the experience of living in perpetual soft twilight at the edge of the solar system, in a world where the universe is always visible and the sun is humble enough that the stars are never hidden. These would not replace Earth's traditions, any more than the development of new cultures has ever simply erased what came before. They would add to them, layer over them, argue with them, and gradually, over centuries, the philosophical and spiritual landscape of the solar system would become as diverse and complex and rich as its physical landscape. And then the governance. Colonies living far from Earth for centuries could eventually create new forms of government adapted to the challenges of planetary life. This, too, is a pattern as old as human settlement. Colonies develop their own governments because they have to, because the problems they face are not the problems of the civilization that founded them, and the solutions that work in one environment do not simply transplant to another. The American Revolution was, among other things, a recognition that a government designed for the particular conditions of 18th century Britain was not suited to governing a population living on a different continent with different economic conditions and different concerns. A Neptunian colony, separated from Earth by light hours of communication delay, with a population shaped by centuries of dim light living and the particular social structures that isolation and self-reliance produce, would not be well governed by institutions designed for Earth. It would develop its own institutions, its own constitution, its own particular balance between individual and community, between local and interplanetary authority. And space law would become one of humanity's most important political challenges as planets debated territory, trade routes, and the rights of new colonies. Who owns the asteroid belt? Who has authority over the trade routes through the inner solar system? What rights do the citizens of a colony founded 300 years ago have relative to the founding civilization? These are not abstract questions. They are the kinds of questions that, on Earth, have been answered by treaties and wars and centuries of negotiation. In a solar system of many worlds, they would need to be answered again from scratch, with the added complexity of distances and communication delays and populations that had genuinely diverged from one another in ways that made easy mutual understanding difficult. The answers would not come easily. They never have. The political history of an interplanetary solar system would be as complex and contested as the political history of Earth. As full of competing interests and genuine disagreements and the painful, slow process of finding arrangements that enough parties can live with to make cooperation possible. But the fact that it would be difficult does not make it less important. It makes it more so, because the alternative to finding those arrangements, the alternative to the patient, frustrating work of interplanetary politics and law, would be the fracturing of a civilization that had achieved something extraordinary. The loss of the connections between worlds that had been built at such cost and over such time. A solar system civilization would have every reason to do that hard work. Every reason to sit across whatever table the interplanetary equivalent of a table was, and negotiate and argue, and eventually find a way forward together. Because the thing they would be protecting, the connected, diverse, extraordinary civilization that had grown from one small blue world to fill an entire solar system, would be worth protecting. Worth the difficulty, worth the patience, worth everything. There is a question that children ask sometimes that adults tend to answer too quickly. Where are you from? Adults have practiced answers to this question. They name a city, a country, a region. They have learned which level of specificity is appropriate for which context, how much detail is welcome, when to elaborate and when to keep it brief. The answer has become automatic. A piece of personal information, filed and ready, delivered without much thought about what the question is actually asking. But children, when they first encounter the question, sometimes pause, because they sense correctly that it is more complicated than it appears. Where you are from is not just a question about geography. It is a question about origin, about belonging, about the place that made you. And the answer to that question is not always simple, even on a single planet with a finite number of countries and cities and villages. Even here on Earth, the question of where a person is from can carry layers and complications and histories that a single city name does not capture. Now imagine asking that question in a solar system of habitable worlds. Where are you from? Asked of a person born on Mars to parents who emigrated from Earth, who grew up under a dust-reddened sky and learned to walk in 38% gravity and has never in their life felt the full weight of Earth's pull or seen the sun as large as Earth people see it? Where are you from? Asked of a child born on a floating habitat above Jupiter, who has never stood on solid ground, who navigates by atmospheric pressure gradients the way Earth children navigate by street names. Where are you from? Asked of someone born in the belt between worlds belonging to no planetary surface, identifying with the space between things rather than the things themselves. The answers would be new. The identities would be new. And the process by which they became new, the gradual, generational, inexorable process of people becoming their worlds, would be one of the most profound transformations in human history. Over centuries, people born on different planets might begin identifying themselves less as citizens of Earth and more as Martians, Venusians, or residents of Saturn's skies. Not through any act of political rebellion, not through any formal declaration of independence, but simply through the natural accumulation of lived experience on particular worlds. The way any identity forms, through childhood, through the particular sky you grew up under, through the language your parents spoke and the food they grew and the stories they told and the games you played in whatever gravity the world offered you. Identity is made of specifics, of the particular and the local and the daily. And the particulars of life on Mars are different from the particulars of life on Earth in ways that run deeper than politics or culture. They run down to the body itself, to the way the ground feels underfoot, to the quality of the light, to the rhythm of the day and the length of the year and the precise shade of the sky at noon. A Martian child growing up with all of those particulars would be Martian in the same way that a child growing up in a particular valley or on a particular island is of that valley, of that island. Not because they chose it, not because they decided to identify that way, but because it is what they are made of. The world entered them as it entered all of us, through every experience of every day, and became part of the structure of who they are. And for that child, Earth would be something else. Something important, certainly. The origin point of their species, the source of their language and much of their culture, the world that all the stories start on. But not home, not the place that shaped them, not the ground their body learned to understand. Entire generations could live and die without ever visiting Earth, knowing it only through stories, history lessons, and ancient recordings. This is not as strange as it might first seem. Most people on Earth today have never visited the places where their most distant ancestors came from. The specific valley in Ethiopia, the particular patch of savanna in East Africa, where human evolution did much of its most important work. These places are remote and inaccessible to most of the people whose existence they made possible. We know them, if we know them at all, through science and story. They are origins, not homes. Earth would become that for the people of the outer worlds. An origin, a story, a place so important in the abstract, so foundational to everything that came after, that it had taken on a quality that was somewhere between history and mythology. Young people on Neptune, in the dim, star-soaked classrooms of their underground cities, learning about the pale blue world where everything began, where the first fire was lit and the first city was built and the first ship was launched and the first rocket left the atmosphere, would feel about Earth something like the feeling you get reading about a very ancient and very significant place you have never been. Reverence, perhaps. Curiosity, certainly. A kind of love, even for a place you know through its influence on everything around you but have never directly experienced. And the idea of going to Earth, of making the months-long journey to the inner solar system, descending into that strong, pulling gravity, breathing that particular air, standing on the ground where the whole story started, would carry a weight that no other journey could quite match. Not a tourist trip, something closer to a pilgrimage. The idea of home, in all of this, would become something more personal and more diverse than it has ever been in human history. As billions of people grow up under completely different skies, climates, and worlds, the word home would stretch to hold all of their different answers. Not one definition, but many. Not one sky that everyone recognizes, but a whole solar system of skies, each one home to someone, each one the particular and irreplaceable sky of someone's childhood. And what would be gained in all of this expansion was something that the people who remained on Earth would also feel. Because a civilization spread across multiple worlds is a civilization that has changed its relationship with the possibility of catastrophe. If every planet became habitable, humanity's fear of extinction from a single planetary disaster would decrease, because civilization would no longer depend only on Earth. We live, at present, in a situation of extraordinary fragility. For all the resilience of the human species, for all the adaptability and ingenuity that has allowed us to survive ice ages and plagues and the slow grind of geological change, all of us, every human being who has ever lived, every human being alive today, every record of human thought and art and science and love, exists on one world. One world in one solar system around one star. If something catastrophic happened to that world, an asteroid impact of sufficient size, a volcanic winter of sufficient severity, any of the scenarios that have, over the 4.5 billion year history of Earth, periodically reset the conditions of life, there would be no backup, no second copy, no other place where the story continued. In a solar system of habitable worlds, that changes. The story would be running on multiple worlds simultaneously. An extinction event that destroyed Earth, however unlikely, however unthinkable, would not end humanity. The populations of Mars and Venus and the Belt and the outer worlds would continue. The libraries and the music and the languages and the memories would continue. Not unaffected, the loss of Earth would be a wound in the collective psyche of the solar system civilization that no amount of time would fully close. But not terminal, not the end of everything. There is something deeply comforting about that thought, held quietly at the back of the mind. The knowledge that the things you love are not uniquely vulnerable, that the world that contains them is not the only place they live. Humanity, spread across an inhabited solar system, would be a humanity that had finally, after its entire long history on a single fragile world, made itself a little harder to lose. And Earth itself would breathe easier for the expansion. As humanity spreads across many planets, Earth's population pressure could decrease, allowing large parts of nature to recover over centuries. The strain that 8 or 10 billion people place on the ecosystems of a single planet is enormous. The land use, the resource consumption, the carbon and the pollution and the simple physical pressure of so many human lives being lived simultaneously on one world, all of it takes its toll on the natural systems that were here long before us and that sustain us whether we acknowledge it or not. A gradual redistribution of population across multiple worlds. Not a forced migration, not an evacuation, but the natural movement of people toward new opportunities and new places would give Earth something it has not had in thousands of years. Room. Not emptiness, not abandonment, but a reduction of pressure. Forests that were cleared for agriculture were allowed to regrow. Rivers that were dammed and diverted allowed to find their old courses. Species that were pushed to the edges of viable habitat given back the space they need to recover. Over centuries, an Earth with a smaller human population and a civilization rich enough not to need every square kilometer of productive land might look genuinely different. Greener, perhaps, in the places where green had been lost. Wilder in the margins. The great urban centers are still present, still glittering, still home to millions. But around them and between them, the living world returns, doing what it has always done when the pressure is lifted, finding the available space and filling it with life. Some planets in this inhabited solar system might be set aside entirely for that purpose. Scientific sanctuaries dedicated to research, preserving untouched ecosystems and studying alien environments. Worlds where human settlement is deliberately limited, where the scientific value of leaving things undisturbed is recognized as greater than any resource that could be extracted. Places that exist not for what they can provide, but for what they can teach. the value of such sanctuaries would be enormous, because the ecosystems that would develop on habitable worlds, given time, given stability, given freedom from the full weight of human intervention, would be extraordinary laboratories. Places where biologists could study the development of life under conditions entirely different from Earth's. Where the questions that cannot be answered on Earth, because Earth's ecosystems are already so thoroughly shaped by billions of years of evolutionary history, might find answers. And for the astronomers, the inhabited solar system would offer something equally precious: perspective. Scientists living on outer planets would have clearer views of deep space because of darker skies and reduced solar glare. This is a practical and wonderful consequence of spreading human presence across the solar system. The farther from the sun you are, the dimmer it appears, and the less it dominates the sky. From Neptune, the sun is a star bright, certainly, but not the overwhelming disk that it is from Earth. The sky around it is dark, and the stars are visible even in the relative daytime, and the great structures of the universe, the neighboring stars, the distant galaxies, the delicate tracery of the Milky Way, are visible with a clarity that no Earth-based observatory, however sophisticated, can quite match. A fully habitable solar system might encourage humans to build giant observatories on distant worlds, giving astronomers completely new perspectives of the universe. Not just optically, but conceptually, because astronomy, as it has developed on Earth, is inevitably shaped by Earth's particular position in the solar system. The things that are easy to see from Earth, the angles of observation available from Earth's particular location, the interference of Earth's particular atmosphere, all of these have shaped what astronomers have studied and how. From different worlds, different things become easy and different things become difficult, and the accumulated perspective of observatories scattered across the solar system would be something fundamentally more complete than any single vantage point could offer. Astronomy from an inhabited solar system would not just be better equipped. It would be differently minded. The questions that astronomers ask are shaped by what they can observe and where they stand when they observe it. Standing in multiple places simultaneously, seeing the universe from 8 planets and dozens of moons, human astronomy would be transformed. Not just refined, not just expanded, but genuinely changed in character. Asking questions that could not have been formulated from a single world, because formulating them required the kind of perspective that only comes from truly being in multiple places at once. And if astronomy changed, so too would the deepest human questions that astronomy feeds. The questions about where we are, and what surrounds us, and whether any of it contains others. Those questions, already profound from Earth, would take on new dimensions in a civilization that had already answered, at least partially, the question of whether life could exist elsewhere. A civilization that had spread itself across an entire solar system and in doing so had demonstrated, conclusively, that life is adaptable, that it finds ways, that the universe accommodates it more generously than we once feared. Future historians might divide human history into 2 eras: the time when humanity lived only on Earth, and the age when civilization spread across the solar system. This is a division that would be clean in a way that most historical divisions are not. Most historical turning points are debated, their exact location disputed, their significance reassessed by each generation. But the moment when the first permanent, self-sustaining human community existed on a world other than Earth would be unambiguous. Before that moment, we were a one-world species. After it, we were not. The boundary would be real and recognized and remembered. The first era, the long, deep, single-world era, would be understood differently in light of everything that came after. Not as a failure, not as a limitation, but as the necessary foundation. The billions of years during which Earth developed the life that eventually became us. The millions of years during which our ancestors slowly, painfully became human. The thousands of years of civilization, of language and agriculture and philosophy and science and art. All of it, in retrospect, as the preparation for what came next. the deep root system of a tree that was always going to grow beyond the patch of ground it started in. We would look back at the first era with love, with the particular tenderness reserved for origins, with the knowledge that everything we became because of what Earth made us, the gravity that shaped our bodies, the sky that inspired our wonder, the seasons that taught us time, the other life that taught us what life was and made us feel, from the very beginning, that we were part of something larger than ourselves. We always were. We just needed time to find out how much larger. Let us slow down now. We have traveled a great distance in this telling. From the first imagining of a solar system transformed, through the extraordinary variety of its worlds and their skies and their weathers and their creatures, through the architecture of cities built in clouds and under ice and in the amber light of rain, through the gradual generational divergence of human cultures across 8 planets and dozens of moons, through the politics and the languages and the music and the philosophy of a civilization that had finally, after all its history, made itself at home in more than one place. It has been a long journey, and we are, in a sense, only just beginning, because the solar system, extraordinary as it is, as vast as it seems when you are inside it, traveling between its worlds, navigating its distances, living under its varied skies, is itself just one small corner of something unimaginably larger. One star, one family of planets, in a galaxy of 400 billion stars. And that galaxy, in turn, is one of perhaps 2 trillion galaxies in the observable universe. We will not travel there tonight. The distances are too great, even in imagination, to cross in a single telling. But it is worth holding that context at the edge of everything we have described. Worth remembering that the solar system civilization we have been imagining, extraordinary as it is, exists against a backdrop of almost incomprehensible scale, and that the habits of mind it develops, the patience, the adaptability, the willingness to think on timescales longer than a single human life, are the habits of mind that any civilization with truly cosmic ambitions would need. For now, let us simply be here, in this imagined solar system, warm and inhabited and alive, and let us think about what it would mean to live in it and remember it and pass it on. If every planet became habitable, humans might eventually stop thinking of the solar system as empty space and begin seeing it as one giant connected civilization. This shift from thinking of space as the absence of things to thinking of it as the presence of something is perhaps the most fundamental change of all. Not a change in the physical reality of the solar system, but a change in the human relationship with it. A change in the way it is held in the mind. Right now, when most of us think about the solar system, we think about the planets as islands in a vast ocean of nothing. The distances between them feel like voids. The space between Mars and Jupiter, the long empty stretches that a spacecraft must cross to get from the inner solar system to the outer, these feel like absences. Like the space between things rather than like something in themselves. But an inhabited solar system would not feel that way. The space between the worlds would be full of ships making their months-long passages, full of relay stations pulsing with signals, full of the invisible lines of commerce and communication and family connection that make a civilization rather than just a collection of separate places. The distances would still be real. The journey times would still be long, but the space through which you traveled would feel inhabited, purposeful, part of something. The distance between habitable planets would still be enormous, meaning that even in a fully livable solar system, space travel would remain a slow and patient journey for many years. There is no shortcut across the solar system. The physics that governs how fast a ship can travel, how much fuel a certain velocity requires, how long a certain journey must take, those do not change because the destinations are more appealing. A voyage to Neptune is still a voyage of months, perhaps years. A message to Pluto still takes hours to arrive. And Pluto, at the very edge of what we have been imagining, a habitable Pluto would experience extremely long years, with one orbit around the Sun lasting about 248 Earth years. Let that number sit for a moment. 248 years. From the perspective of someone born on Pluto, the Sun would complete a full circuit of its path through the Plutonian sky once every 248 Earth years. A single Plutonian year would span the lives of several human generations. A person born at the start of a Plutonian spring would die of old age before Pluto reached its summer. What would time mean in such a world? What would seasons mean? What would the very concept of a year, that fundamental unit of human timekeeping, the time it takes to go around once, the period that organizes our calendars and our ages and our sense of the rhythm of things, mean to people for whom a year was longer than recorded human history? The Plutonians would develop different ways of counting, different ways of marking time. Perhaps smaller cycles, the orbital period of Pluto's largest moon, Charon, which takes about 6.5 Earth days, would serve as the basic unit of the Plutonian calendar. Or perhaps the Plutonians would simply have a different relationship with time itself, less concerned with cycles, more attuned to the long, slow unfolding of things. The kind of patience that a world with 248-year years might cultivate in its people. And while those people were living their long, patient, dim, starlit lives at the edge of the solar system, the worlds closer to the Sun would be changing in their own ways, accumulating history the way inhabited places accumulate history, layer by layer, generation by generation. Earth's ancient landmarks, the pyramids, the great temples, the oldest cities, could become protected heritage sites visited by tourists from across the solar system. Think about what it would mean for the pyramids of Giza to be visited by someone who grew up on a floating habitat above Saturn. Someone for whom solid ground is already a novelty, let alone ground that is several thousand years old and shaped by human hands into structures that have outlasted every civilization that came after the one that built them. The experience of standing at the base of one of those pyramids, feeling the full weight of Earth's gravity, which is heavier than anything they know, and looking up at stones placed by human beings in an era so remote it is almost mythological, would be unlike any experience available anywhere else in the solar system. Earth would become the museum of humanity, not a dead museum, not a place preserved under glass, but a living museum, a world still fully inhabited, still changing and growing in its own right, but also carrying within it the oldest and deepest record of what humanity is and where it came from. The streets of Rome, the ruins of Athens, the cave paintings of Lascaux, so old that the civilization that made them barely registers in the history books of a solar system civilization. All of them are still there, all of them carrying their weight of human time. Over thousands of years, myths and legends would emerge about the old Earth. Not just history, mythology, the kind of story that grows up around a place of great significance when enough time has passed that the historical record blurs and the imagination fills in what memory no longer holds clearly. The stories would probably get some things wrong. They always do. The specific details would fade and be replaced by the details that the stories needed. The symbolic weight of the original home, the garden world, the blue planet where everything started, would grow larger with each retelling, until old Earth occupied a place in the mythology of the solar system civilization that was somewhere between history and religion. Future generations might look back at humanity's early space age the same way modern people view ancient ocean explorers crossing unknown seas. We know the names of some of those explorers: Magellan, Columbus, Zheng He, Cook. We know in outline the shape of what they did, but the specific experience of it, the precise quality of the fear and the wonder and the discomfort and the extraordinary moment of first sight of an unknown shore, is gone. We can reconstruct it with imagination and scholarship, but we cannot recover it. It happened once to specific people in specific bodies, and when they died, the direct experience died with them. The first people who truly lived on Mars, who built the first permanent structures and raised the first children and buried the first dead in Martian soil. Their specific experience will eventually occupy that same place. Known in outline, celebrated in legend, but unreachable in its particularity. The way we feel about the first ocean crossings, that mixture of admiration and wistfulness and the humbling awareness that we are the inheritors of extraordinary courage we can barely imagine. That is how the people of the inhabited solar system will feel about the first planetary settlers. And they will be right to feel it, because what those first settlers did was extraordinary. Not just technically, not just in terms of engineering and logistics and the sheer physical difficulty of keeping human beings alive on worlds that did not want to keep them alive, but in terms of the imagination required, the willingness to go somewhere genuinely new, to build something genuinely different, to become, over generations, genuinely other than what you were. If every planet became habitable, humanity's sense of scale would change forever, making the solar system feel less like empty space and more like a vast cosmic homeland. This is perhaps the most quietly revolutionary change of all. Not a political revolution, not a technological one, but a perceptual revolution. A change in the basic texture of human experience. In the ordinary, daily, unreflective sense of where you are and how large the world is and what it contains. Right now, for most human beings, the solar system is abstract. We know it exists. We have seen the photographs and the diagrams and the animations. We understand intellectually that we live on one of 8 planets orbiting a star in a galaxy of 400 billion stars. But we do not feel it. Not in the bones, not in the daily lived experience of being a body in a place. The solar system is a fact, not an experience. For the people of an inhabited solar system, it would be an experience. Not something known about, but something lived in. The sky above them would not be an abstract diagram. It would be home, or the view toward home, or the direction you looked when you thought about the people you loved in another world. The distances would not be abstract numbers. They would be the length of journeys taken, the duration of separations endured, the size of the space that had to be crossed to get from where you were to where you wanted to be. Humanity would no longer feel confined to a single fragile world. It would feel, and this is a feeling without good precedent in human history, because no human civilization has ever been in a position to feel it, part of something that exceeded any single world. Not just intellectually, not just as a fact about the species, but personally, emotionally, in the way that you feel part of a family even when the family is scattered and you see them rarely. The knowledge that the people you are connected to, the civilization you are part of, extends across a solar system, that it has roots in 8 different soils and lives under 8 different skies and counts its years in 8 different lengths, would be a different kind of belonging than any human being has ever felt. The solar system itself would begin to feel less like a collection of distant planets and more like a shared cosmic continent filled with life and memory and history. A continent that took months rather than days to cross. That had climates ranging from the tropical warmth of a habitable Venus to the cold, dim quiet of the outer worlds. That had its old settled regions and its newer frontiers, its centers of culture and its remote outposts, its well-traveled roads and its lonely paths that only a few had ever followed all the way to the end. Continent with stories, with the particular stories that places accumulate when people live in them long enough. The story of the first dust storm on Mars that covered half a continent and lasted for 6 months, and the people who waited it out together and what they did to pass the time. The story of the European deep-sea expedition that descended further into the subsurface ocean than any previous mission and what it found there. The story of the great Saturn storm that became a landmark, named for the explorer who first mapped its edges, whose name is still given to that particular swirling column of cloud by every navigator who passes through that part of the atmosphere. Stories. The thing that makes a place rather than just a location. The thing that makes a civilization rather than just a population. The accumulated, particular, irreplaceable texture of human life, deposited layer by layer over time, in every world that human beings have made their home. And for the first time in human existence, the night sky would no longer represent unreachable worlds. It would represent homes, countless homes, waiting beneath alien suns. Stand on the surface of any habitable world, on any clear night, and look up. The stars are there, always the stars. The same stars that human beings have looked at since before language, since before fire, since the very beginning of whatever it is we are. The stars that inspired the first myths and the first navigation and the first scientific questions and the first understanding that the universe was larger than the world we lived in. Those stars have always been the great symbol of the unreachable. Beautiful, present, ancient, and impossibly distant. There but not there. Visible but not visitable. The night sky, through all of human history, has been the most eloquent expression of the limits of the possible. Here is what exists, it said. Here is what surrounds you, and here is what you will never touch. In an inhabited solar system that changes. Not because the stars become reachable, they remain as far as they ever were, as far as they will always be. But because the relationship between human beings and the night sky changes. Because the sky is no longer a symbol of what is out there and inaccessible, but a map of what has been reached and inhabited. Those planets that were once just points of light, those wandering stars that the ancients named and watched and wondered about, are now places. Homes. Worlds where people live and grow food and raise children and argue about politics and make music and fall in love and bury their dead and look back at their neighboring worlds with exactly the same wonder that we, tonight, feel when we look at them. The night sky in this imagining becomes a different kind of beautiful. Not the beauty of the unknown and the unreachable, but the beauty of the known and the beloved. The beauty of looking across a distance and seeing, however faintly, the light of somewhere that matters. Somewhere that is part of your story, even if you have never been there. Somewhere that is part of the larger story of what your species has made of itself, and where it has gone and what it has found when it arrived. We began this journey with a question. A simple one, asked with the kind of quiet wonder that the best questions carry. What if every planet in the solar system became habitable? And the answer, it turns out, is not a simple one. It is not a list of facts or a catalog of changes. It is something larger and stranger and more human than any list could capture. It is the story of what happens when the space we live in grows larger than the space we evolved to live in. When the world that made us is no longer the only world we call home. When the night sky stops being a limit and starts being a landscape. It is, in the end, a story about belonging. About the extraordinary human need to find home in whatever place we find ourselves. About the patience and the ingenuity and the courage required to build something lasting in unfamiliar territory. About what it means to be a species that looks up, always up, and wonders and reaches and goes. We are early in that story. Very early. The first tentative steps have barely been taken. The first distant shores are barely glimpsed on the horizon. But the ships are built. The direction is known. And the night sky, as it always has, is full of light and waiting.